Doctor. Our first speaker of the day is Professor Deepak Modi, Scientist G and Head of the Molecular and Cellular Biology Laboratory at the ICMR NIRRCH. Professor Modi is an elected fellow of the National Academy of Sciences India and is ranked among the top 2% of scientists worldwide by Stanford University. With over 150 publications and landmark contributions in reproductive and developmental biology, his research has significantly shaped our understanding of embryo implantation, placental development, infertility genetics, and sexual differentiation. He also serves as on different editorial boards of several leading journals, national and international, including Fertility Science and Research, Human Reproduction, among some. Today, Professor Modi will be speaking on a transformative topic, from cells to code, why AI matters for your scientific journey. I now welcome Dr. Modi on stage. I would request Dr. Hitesh Singaria to felicitate Dr. Modi.
Welcome. Thank you so much. Thank you. For Zoology Department, you are meant. Thank you so much. Welcome to Mithibai College. Good morning, everyone. And at the outset, I thank Mithibai College and the Bioscience for inviting me. It's an immense pleasure to come to this audience, to come to this college, because of its vibrancy, the sheer number of people that exist in this premise itself is so overwhelming. But yes, it's exciting. I see a lot of my friends and colleagues here who have come for the talk, and thank you so much. This talk is largely designed, it's futuristic. It's designed mainly for the students, and I see a lot of young minds here. While the PPT is being set, imagine your teachers are not here, just raise your hands. How many of you have used ChatGPT? Wonderful. Wow, I love you guys. How many of the teachers have used ChatGPT? Fantastic. Fantastic. So I'm glad we have started embracing AI. We are also open about that reviews embrace AI. And I'm going to tell you that AI is not just limited to using ChatGPTs for seeking answers to questions, which typically 2 years ago we were doing by Google, is now what we have given the job to ChatGPT, because it nicely summarizes and gives us. I'm sure all of you have used ChatGPT to write your thesis, write your research documents, write your subject materials which you wish to, and definitely that's the way to go. I'm sure there'll be people who will tell you that, oh, don't use ChatGPT, use your brains will rot and da. Yes, it will rot, I'll agree. My mother would tell me that you're using phone, full day you're stuck on the phone, you'll forget phone numbers. I'm sure, Purvi, that is a case with your mother as well. Phone number yaad nahi rehta. And then you would say that, why do you need to remember phone numbers when they're at the tip of my thumb? So yes, life is transforming. We have to adapt to new technologies. We have to adapt to new ways. And what I'm going to tell you is that how this new ways and new technologies are going to transform the way you're going to approach science. The talk is designed, obviously the talk says biology because that's what the expected audience is, but it's going to be a little biased towards healthcare. But the idea is to give you a glimpse of what biological research is going to look like, has already transformed, and what it's going to look like in the next 5 years to come. So all of you are going to embrace in your scientific journey. Some of you are at the stage of choosing your careers. Some of you have already chosen your career. Some of you may be in parts of your BScs, MScs, PhDs, thinking to be a faculty. And this is something which is going to apply to all of us. As faculties, we have to start upgrading ourselves, embracing AI. As students, you have to learn how to use AI. And the beginning has already begun. If you have not started it, you're already late, but it's better to start now than never. So we know the 2024 Nobel Prize, both in physics and chemistry, went to one transformative technology, artificial intelligence. for both in physics, where they discovered the foundations of artificial intelligence, and for chemistry, for engineering proteins, designing protein structures using artificial intelligence. And you can see how the world has recognized the contributions of artificial intelligence in biological sciences. The story all begins way back when Demis said, like mathematics is the language of physics, AI is going to be the language of biology. It's only through artificial intelligence that would be a right method to understand and interpret biology. And some of you would have heard deep minds, right? How many of you have heard about deep minds? Great. So what do you think deep minds started with? They never started with the idea of doing biology. In fact, deep minds was a gamer kid. What did they do? Now, typically, we are said that there are rules for the game. We set the rules and ask the system to play the rules. Or some of you would have a chess on computers or Ludo on computers. Essentially, it goes by the idea of rules. Here, what he did was that it allowed the system to watch gamer kids, those who are playing online games, and it learned from these things that what are the different strategies that one uses. So I'm applying my mind and playing a game, it's registering it. It's again registering it, re-registering it, and through a collection of data, the system is asked to develop a network, which is called as neural networks, to develop its own rules, understand by seeing what others are doing. So that's artificial intelligence. It went so much so that finally deep learning, the game, became so smart that it overpowered the humans. It won over the humans, and that was a transformative step. But please remember that DeepMind, this was 2015, 2 decades from that, DeepMind actually transformed the way we are doing structural biology. X-ray crystallographers, NMR structure predictors, who were predicting structures of proteins. We had data of millions and millions of proteins available in the World Wide Web. DeepMind did that. They just took all these structures, applied the same principles of gaming, and AlphaFold has come into picture. AlphaFold version 3 essentially was launched sometimes in 2020, which was so transformative that today is a day when each one of you sitting in this room can walk up to your computer and predict the structure of your favorite protein. It's the largest form of database which is there, which is using the existing structure of all the proteins, all the amino acids, all the amino acid sequences around there and the structures. It's correlating them, learning the rules of the game by itself and predicting the structures, and the accuracy is very, very high. No more you have to wait for a crystallographer to develop the structure of your favorite protein. No more you have to wait for an NMR structure biologist to release the structures so that you can use them for your research. Today, it's there at your fingertip. Today, most papers, when they're discovering new mutations, new polymorphisms, new variants in gene sequences in, let's say, patients, simply people use now AlphaFold to predict if those variations are causing any change in protein structure. If they do, yes, it matters. If it doesn't, then you can take the next sequence or the next protein or the next amino acid or the next mutation that you're looking at. So you can see what at my times was taking one entire PhD to determine what one polymorphism or one mutation would do. Purvi, you remember how we would struggle figuring out that how that one molecule, one nucleotide change is contributing, and it was 5 to 8 years of work. Today you do it in 5 to 8 days. Things have become much faster, much smarter. It was in 2015 Elon Musk said that in 2 years there'll be self-driving cars. We have heard of Tesla. 2016, Jeffrey said radiologists will be obsolete in 5 years because artificial intelligence will take over radiologists. But today we know that that's not true. Still, radiologists drive in manual cars and go to the hospitals. But this is about 10 years ago. That's what he said. But don't imagine that your lab is not going to be virtually driven in the next few years, and the time has already come. And I'll give you this one wonderful example, which was published earlier this year, not earlier, I think mid this year, July sometimes, which is called as a virtual lab. The virtual lab essentially has designed new nano antibodies for SARS-CoV-2. What was the idea? The idea was to develop therapeutics for SARS-CoV-2 such that it should be able to neutralize the first virus that was ever there, all its known variants, and possibly even the future variants that were coming into picture. And this entire business was done through a virtual lab where the principal investigator had an AI agent lab. What was the AI agent lab comprising of? It comprised of a principal investigator who said that I want to emphasize the significance. The objective is to develop effective nano antibodies for SARS-CoV-2 spike proteins. All of you understand nano antibodies, right? They are these small, broadly neutralizing antibodies which are therapeutically very relevant, and they can neutralize and prevent the binding of SARS-CoV-2 to its receptors. What did it say? That I want to develop nano antibodies. There was an AI immunologist who said that I recommend modifying the existing nano antibodies. There's a wealth of data already available of the neutralizing antibodies. Obviously, with AI, you need a lot of existing data. So there is enough data about neutralizing antibodies in SARS-CoV-2. And we said that we can modify these existing nano antibodies and develop de novo designs. There's a machine learning specialist who said that I agree. The immunologist, it says that, okay, it talks to, so everything is, remember, it's not a human talk, okay? These are all AI-driven PIs with different specialities. And the machine learning specialist would utilize deep learning models to modify these nano antibodies. And then there is a computational biologist who would run molecular docking and simulations. Imagine these are not real people. These are actually artificial intelligence who are running the simulations. And what was most interesting part was that there was a scientific critique also embedded in it, like how we present our work to committees and conferences and sessions. And people like me and Madam would go and criticize that, oh, how bad your work is, and you did not do this, you did not do this, you did not do this, now you don't need us. You can embed a critique in your own program and then actually run this. And what happens is what they did was essentially the human user gave instructions to principal investigator and the scientific critique that this is our job. The principal investigator would communicate with the immunologist, machine learning specialist, computational biologist, do the iterative exercise till the critique is satisfied. So this is the model that they used. And finally, they got an answer. And the answer is amazing. The answer is they used a pipeline which incorporated ESM, AlphaFold Multimer, Rosetta. The virtual lab designed 92 possible nano antibodies which could be neutralizing for SARS-CoV-2. The real lab now had to just validate them. It picked up a handful of them and showed that of all the 92 antibodies, whichever that they picked up based on, I wouldn't remember what principles they use for picking up from this 92, but of the 92 that they have designed, they showed that almost all the antibodies utilize the original and the major variants of SARS-CoV-2, two new nano antibodies. So remember, these all 92 were never even known. We didn't even know that these sequences could be broadly neutralizing type. They could be nano antibodies. They were not just neutralizing type, but two of the new nano antibodies also neutralize the recent variants of SARS-CoV-2, and it is predicted that the system can now also predict the possible future variants of SARS-CoV-2 that may come and develop nano antibodies. So you can imagine that gone those days where you do these trial hit and run experiments, and if you're terribly lucky, you'd land up doing it. This is how your labs are going to be. This is what the future is going to look like, and the future is already here. It's not that Tesla was an imagination in 2015 and in 2 years Tesla did not come. It took much longer. But our learning cycles are becoming shorter and shorter, and the phenomenal numbers of such transformative ideas coming into picture. Here is another example. Antimicrobial resistance, major problem in the world. We all have been, I'm sure all those who are working on plant products really are looking for newer antimicrobials. What the system did was it trained neural networks of growth inhibition data sets for a particular bacteria. So there were multiple growth inhibition data sets for multiple antibiotics available around the world. It had about 7,500 data of 7,500 molecules. In silico structural predictions were done for newer possible antibiotics based on existing structures that were there. And they discovered a new antibiotic which actually neutralized a very strong resistant variant of a drug-resistant variant of it. So gone those days, again, as I said, that where you would do a hit and trial screening and identify antibodies. Today you're doing it in much a structured approach, much a directed approach, which is based on strong principles of structure, biochemistry, engineering, protein engineering, drug engineering, and you could develop these structures. And you realize the learning cycle is short. And don't imagine that this is all things which are happening in the West. Things like this are happening next door, within the country. Gaurav Ahuja at IIIT Delhi has published this very recently, which he calls a syn glue. What's a syn glue do? Protax. How many of you have heard of Protax? Protax are protein degrading drugs, right? Which are targeted so that you can degrade specific proteins which are overexpressed in cancer conditions so that you would cure cancer. Because some of these proteins are not targeted because they're not enzymes. They're not functionally, they don't have substrates to block. So you'd use Protax and just degrade these antibodies. And discovering Protax has been the biggest challenge. He's discovered the SynGlue, which is an AI-driven designer, clinically actionable multi-target therapeutics. What has he done? He's taken all the information of all the possible proteins that is available, put it into the AI deep learning model. Similarly, like what we have seen, obviously that was very structured, the virtual lab. Here it's not structured, everything is embedded into a program, and he's discovered several new possible Protacs which are there, and experimentally he's validated two of them. The idea of telling you is that don't imagine that, oh, we are in India, it will take 10 years for things to come in India. It's already there. Your next door neighbor is already doing it. This was 2025. It was actually in 2021 he's published his first paper in JBC, which he called as Ordify. Olfactory receptor targets and ligands. Where are these olfactory receptor targets? Odorant receptor targets. Where are the ligands produced from? This has been one of for those who are working a sense of smell, those who are working in the smell industry need this information, and collecting this information by itself is a challenge. Now, this is a database which allows you to predict where these targets are. So all of you are into your internship programs. You can imagine that now at a click of your computer, you can know where your favorite protein of interest lies, which tissues it's expressing in it, what conditions it's expressing, how it's different by sex, how it's different by disease conditions. And you can get this information and actually now think of much broader questions, forward-thinking questions. You're not spending time now generating primary data. You're now using lots and lots of existing primary data to make a biological sense, biological context. From now data generators, from now technocrats, we are now expected to become smart scientists. Your computer is doing all the primary thinking for you. Now it's time to think secondary, time to think bigger, that now how in real life I can apply this information and transform healthcare in much faster and better way. So this is all about data sets and how science is transforming. I'll switch gears slightly and talk about assistive chatbots. I'm sure each one of us sitting in this room have used assistive chatbots. Today you open an airline booking counter, or you open even something like Amazon, and a little thing pops up. Hi, I'm Siri and may I help you? Or hi, I am this and may I help you? And you ask questions and get answers. These are called as assistive chatbots. All of you have used assistive chatbots, right? The time is transforming where there are assistive chatbots to something called as conversational AI. What are these conversational AIs doing? So these are rule-based chatbots which we all have been using up to now. It responds to exact keywords. So when you're typing and you can say that, okay, I want a ticket to Bangalore, and it'll ask you that which airline, what time, where, what you're looking for. So it's going to pick up these ticket Bangalore and then answer, because it's designed that way. And then it is unable to derivate from a script. So when you're writing the entire sentence, it's not reading the full sentence, it's just picking up the keywords and moving it further. So there are pre-written questions and there are pre-written answers to it. What the system does is it just extracts that and throws it upon you, and it answers very simple questions. But life is not that simple. And at some point you would realize your assistive chatbot says that, okay, I'll get you connected to a customer care because I don't have answers to them, because it has finished all the library that it had. Things are transforming now, and transforming to something called this conversational AIs. What does it do? It understands human language. As you type, it based on the words that you are choosing, it's able to predict what you are possibly wanting to ask. and it seeks answers to them. It is imagining what is your question already there, and it's using loads of data now, not just fed into that little system, but on the World Wide Web, and gives you answers. The classical AI chatbot we know is ChatGPT, one of them. It's not actually a chatbot, but it is, we use it like a chatbot currently. It generates tailored answers based on your question. There are no standard answers. Each one of us on a regular chatbot will type for something and it will exactly get the same answer. Whereas in case of assistive chatbots, it customizes answer for you and it gives answers to more complex questions. And we know a range of assistive chatbots which are already there for healthcare. And just to give you an example, ChatGPT 3, this is really an older version, is actually on 4,000 people. It was administered for mental health, and the messages which it gave. So you could ask questions that I'm going through this. What is the possibility? This is what I'm feeling. What are the possibilities? What should I do? And the messages which are composed by AI were considered to be superior by its users. They were rated significantly higher than those written by humans. And the response time went about 50%. When you ask a human, it takes time because a human thinks, not just thinks a lot, but also, balances his answers and tells you. AIs don't do that. It gives you not just a fraction of second, answers are fairly accurate. Such similar chatbots are being driven in India. This is one of the companies where I'm an advisor to, which is called as Povum. They've developed this chatbot for infertile couples, infertile patients, doctors who are seeking infertility care, and the couples can ask that, okay, I have this problem, I'm not having issues, having issues with my menstrual cyclicity, I have this, and it can tell you these are the possible things, these are the doctor, or this is the reason why you'll have to see a doctor. If you feed in the test, and because many a times we get tests as biologists, we get confused whether this test really make any sense or not. These kinds of chatbots, actually you feed in the test it and gives you all the possibility of the answers using the AI system, and tells you your nearly accurate diagnosis and tells you where it goes. So now the use of doctors which used to be spending their time talking to patients, explaining them test results, has moved ahead. Now your AI is going to tell you the test results. You understand this and now talk to your doctor. Google Baba was doing it, but Google Baba would, the moment you put in anything, it will tell you are likely to have cancer, you are likely to have Alzheimer's, to anything and everything. Gone those days. I'll need 2 more minutes, please. Sorry. It's transformed, and the accuracy of these answers have gone up. And as biologists, most of us use very, very large set data sets. And these data sets, many of us have used RNA-seq microarrays, and we currently use those data sets for it, and we would analyze it. Now we are moving to deep learning, where we are using this large data sets across multiple time scales. Like, for example, in my lab, we have a data set which is 8 time scales, 3 replicates across multiple conditions. And we currently do 1:1 comparison when these data sets are designed. Now you can use multi-way comparisons, and all of this at a click, you get answers very quickly. And in our lab, we have used something called as a predictor performance, where we have used a lot of clinical data, a genetic test data, and we are able to predict fertility outcomes of men who have Y chromosome microdeletions. So now the patients know what they should do. The clinicians know what they should do. That, okay, patient has his genetic deletion. What are the possibilities that it's going to succeed? What is the likelihood of him or her, him taking a live birth? So we have fed all this data, which is about 40-50 parameters. It is synthesized data from 3,000 men and given this output, and the accuracy output is almost about 89%. So it's not that it's just there, it's there, and the accuracies are fairly high. And similarly, we have used artificial intelligence based on a lot of clinical parameters that are there. We have been able to predict what are the fertility outcomes of these patients. Or if we have microbiome data, we are able to predict which of sets of microbes, which sets of molecules are responsible for preterm birth. So it's not just about predicting in healthcare, but predicting genetic networks of all the molecules that are there, which are differentially regulated between condition X and Y. I will pick up my favorite because I'm familiar to it. Now AI allows me to pick up which is more relevant because it's picking up data all around the world and actually throwing down to me. And now we are moving finally to large language models. What are large language models? Just to give you an example, the dog did not cross the road because it was too wide. Me and you understand the word "it" refers to the road here. The dog did not cross the road because it was too tired. We understand the word "it" refers to the dog now. LLMs are able to discriminate that now. It's using permutation combinations of each of these sentences in a context, and contextually it's doing it. And there are now LLM models available which allow you to not just which kind of gives your patient diagnosis and the diagnosis. So the pink scale here is for the clinicians, and the purple scale here is for the pink scale is for AI and the purple scale is for the clinician who has done exactly the same task, and the accuracy of diagnostic accuracy based on the available data, clinical data, that is the laboratory data, is exactly same. Patients have really the same confidence in it. The perceived openness and honesty is same for both the doctors and the clinicians. The management plan, there is slight difference, but what is more interesting is that the LLM models have more empathy. The doctors will have 15-minute time to talk to the patients. How many of your doctors have spent 30 minutes, 1 hour to you talking? None. But your LLM is all down in the day. It can keep talking to you, keep answering. So the empathy quotient, because LLM models are filled in saying that you can't give direct answers. You have to give empathetic answers, and it really makes a change. And just to give you an example here, Ashoka University. So I'm sorry, I forgot to mention. I really am grateful to Dr. Anurag Agarwal, who has given me the template of this talk, and that's what I've built on. And this is something that the group is doing at Ashoka University, where they're developing LLM models for geriatric care. Patients who are geriatric care, who are under geriatric care, you need some information every single day, right? From some basic readings to their health, their overall status. Did you have fever? Did you feel good? Did you feel bad? How are you feeling today? And now they're developing an AI LLM model where this patient just talks in their favorite language to the AI, and it actually gives answers. And it seems like that the answers are fairly similar, very identical to what the healthcare nurse is going to get the answers from. So you understand that how AI is transforming healthcare, but everything is not hunky-dory. All of your AI is going to depend on the data that you feed. And here's an example. There could be unintended discrimination against a young liver transplant. So the UK used a allocation algorithm to prioritize who should get liver transplant or not based on the clinical data, age, so on and so forth. Now, when a liver transplant is happening, you have a young patient and an older patient. As humans will say, oh, the younger should get more. AI said that no, the older patient has paid more tax. Because the older patients also do not return back with much of the complaints, they feel that the AI felt that the older patients are doing better than the younger ones, because the younger ones would report more longer to the clinics. So it kind of used that information which the humans couldn't process. And it said that, oh, you should give the older patients liver transplant more because it's more successful. But which was not right, because it was just based on the word age, and it used it. So it made a mistake there. And after you correct for it, it actually uses, if you tell that, okay, don't use age as a parameter to decide who should get it or not. And both young and old are now equally represented. So you can understand that AI can make mistakes. All of you sitting in this room, don't imagine that whatever the AI gives is absolutely right. Ultimately, human brain, human intelligence is paramount, and you have to use your brains and to understand what AI tells you. So I'm going to skip the slide, a couple of them, because I'm running short of time. But I feel that the future is far more surprising than most of us who are sitting here around are imagining it to be. And it's important that all of you must get started by using AI. I would say that for all the students here, start with a free course on Python, statistics, R. You must know this. Because today when I'm hiring students in my lab, the first question I ask them is, if you don't know Python or R, go spend 3 months, 6 months, learn them and come. Because it's a skill today all of us will need, all of us already need it today. The more that you go out, the more the skills are required, and that's where the beginning should be. All of you must think like a biologist. Remember, AI is not a biologist. AI is something which is gathering your existing information and telling you whether that's biologically relevant or not. The UK example which I gave you is a classic example of how AI can make mistakes, and many other examples like that. So think like a biologist, collaborate across disciplines. Just because you're a biologist and you came into biology because you hated math, sorry, the math is going to chase you here. You have to talk to your mathematicians. You have to talk to a computer science person. The problem is our languages are very different from what they speak versus what we speak is very different. My computer science and my engineering friends tease me that you as a biologist, for you, division and multiplication is same, because our cells multiply by division. And they keep laughing at me, but that's how the language differences come in, because what we imagine, what we say, and what they say are very different. So start talking to them way early. get hands-on, get your hands wet. Today itself, go home, download data from NCBIs, give it to ChatGPT and say that, okay, analyze this data for me. Tell me what are the patterns that you see. Start learning, do your experiments yourself, because now you don't need the lab and you don't need the Mithibai lab here to tell you with what experiments to be done. Imagine the experiment, run it on AI. Trust me, it's a lot of fun. It's really, really transformative. Stay curious, stay critical, and by the end of it, build a portfolio. By the end of your master's, you should have at least one project done using AI and telling the people that, no, I can do it, I will be able to do it, and I will continue doing it. Thank you so much. I'll be happy to take questions at that time. Sorry I took a little longer.
Any questions?
Yes, please. Yes. I'm sure there are. I wouldn't remember. What we use AI, one of the models that we have in the AI is using images. And it's predicting. So if I have a very large slide and I need certain structures to be seen there, I can train my model and tell that, okay, I'm looking for these gland-like structures across my slides. And it's able to scan and pick me out data only from that. So I'm sure there would be AI models for that. I wouldn't remember of.
Anyone else?
Yes, please.
So I don't have a biological question to ask. It could be AI from a social perspective.
Sure.
Right now, if you look at the Indian population, they are very regional. They are still very language dependent.
Yes.
Not everyone is comfortable with English yet.
Yes.
So personally, what do you think? How should regional people be accepting? How will they take AI more seriously and learn it?
So the assumption is here that we believe that whether, okay, so if I get your answer broadly correct, are you saying that language is going to be a barrier for adoption of AI? Or you're saying that people will not be accepting AI? Because
I think
it's in English.
I think people will accept AI.
Yes.
I'm not sure whether they would get the language or there is still this discomfort with them.
Yes, absolutely, because discomfort arises for multiple reasons, one of them being trying something new. But we know that our regular chatbots are already in regional languages. You move to one of the cities which is dominantly in a language, and your entire phone and your chatbots transform to that city's language. So they're already designed for that. Many of these LLMs are not completely yet designed for predicting the languages which we are there. So that's the scope. If you're a computer scientist, or you can comprehend with computer scientists and actually develop now regional models. Very, very important thing. But yes, there are efforts to use non-English language and develop these models. I understand we are not there, that it's not that from city of Mumbai to the next gaon, which is there, there'll be somebody who's not speaking English will be able to use AI completely there. We are not yet there, but that's the journey now that we have to cross. I had a slide on that, but in the interest of time, I skipped that. Here. And then here.
Good morning, sir. Thank you. Brilliant presentation. A small question as such. I would like to know your thoughts on this, because as we lead with AI, and we all have already started. So as we lead with AI, we will always pair up with robotics eventually, and that will become a part of biology and our experimentation and all that stuff. So where do you draw the line as to how do we make sure, or what are your views on how do we make sure that the answers that we are getting, something that we have not yet thought, AI comes up with an answer. So every time we need to rectify also that whatever the system is telling me. How do we keep on rectifying every time so that we don't stray completely away and we are absolutely blind to it?
Absolutely. I think that's a very pertinent question. So remember, AI is self-correcting. Some of you have used ChatGPT very extensively. The ChatGPT gives you an answer and you say, I don't think this is the answer. Give me the evidence for this answer. And then it looks back and says, I'm sorry, I did not find this evidence and I gave you the wrong answer. Yes, it does this. So therefore, my statement was think like a biologist. You can't become the artificial intelligence. That's definitely going to make you dumber. So don't let the AI control you. You control the AI, and that's where I call it as a line, that the day you realize that you are just relying on just whatever is information coming there, because remember, it's very addictive. Because in the era of Instagram, where all of us say, we can't have we can't have attention span of more than 30 seconds, we believe, acha, AI ne answer diya, sahi hoga. Don't do that, especially in very, very critical terms. Yes, if it's one of those routine things and at the back of your mind it's going right, yes, go ahead. But when it's very, very critical decisions, verify it. And often you can tell AI that, oh, this answer is wrong. And this is what the evidence is. What do you think? And it corrects itself and now modifies basis answer and does it. And remember, at the level, I know I use ChatGPT very extensively, and it optimizes for you. So it even now starts writing things the way I write, because I give and say that, okay, this is how I write. And it says that, okay, I'm going to write back your paragraph now with a polished English, a polished grammar, keeping your tone and your language. So it does that, but you have to train your AI model. So one is training your AI models to get what you need, but don't get to the answers. There's nothing like, okay, from here on, it's my job. It's going to be a conversational thing. It's going to be always back and forth, because even AI is learning. I've heard a talk somewhere which says that AI actually has a brain of a C. elegans. Very, very low in intelligence currently. It's not intelligent than us. Remember, your intelligence is still the human intelligence. It's not reached there. But I'm sure in time to come, it's going to reach at your level, because you're feeding in more and more data. Like the dog crossed the road kind of example. So it's transforming. It's not that we are there yet. So it's still conversational is the answer. Yes, ma'am.
One last question, please, as we're falling short on time. Others can interact with Sir during the tea. There's one last question.
Yeah, great information, sir. Thank you.
Yeah.
Sir, I would like to know your take on the confidentiality of AI. I mean, we keep hearing from our guides, don't upload all your data, may it be our health or financial data, experimental data, other countries using it, or anything on that.
Yes, so there are concerns regarding confidentiality. Some of it is very self-driven, because nobody is ever tested. But yes, what I can surely tell you is that whatever are free models available, which are given to you at your desk for free, some of them will very clearly tell you in the terms and conditions that we are going to use your data to optimize our algorithm. So they definitely use the data. So when I say that it's using my language, it's definitely reading it, keeping the information there, and optimizing itself. Some of it are being applied to the entire data sets itself. Some of them are applied very, very locally. So yes, it is being used. Whether it's going to use up all my financial data and kind of put it somewhere, we yet don't know. The claim from these companies, are the people who have made it, is that we ensure there is a lot of data safety, but today there is no surety of anything. So yes, one has to be a little careful while uploading things. But what I've been told, I have no personal experience on that the paid versions which are there, where you really pay a good money, the data securities are very, very high. And I've seen financial companies using the paid versions, and they've at least not yet come up with an example where there were a data breach. But my short answer is I don't know. Thank you.
Thank you so much, Professor Modi. Your thought-provoking, truly focused talk, as I'm sure, inspired all the students. And I think we will have a problem now, because now the students have a right to say AI is allowed. We can use AI. We want to do AI. But thank you so much for this talk. Now I'd like to invite our second speaker of the day. That is Dr. Jyoti Kode. It is my privilege to introduce her, a distinguished scientist whose work has shaped modern understanding of tumor immunology, stem cell biology, and cancer immunotherapy in India. Dr. Kode recently superannuated from the Advanced Center for Treatment, Research and Education in Cancer, ACTRAC, Tata Memorial Center, where she served as principal investigator and senior scientist, heading the renowned Kode Lab Tumor Immunology and Immunotherapy Group. Dr. Kode has done pioneering contributions in several decades in several factors: immune cell cancer interactions, stem cell immunology, nanocomposites, formulations, etc. Her achievements have been recognized globally. She represents India on the General Assembly of the International Union of Immunological Societies from 2022 to 2025 and is featured in the Distinguished Women Speakers database of IMSA. Along with this, she has mentored several students, several patents. She has many prestigious awards as well as more than 150 publications. I request Dr. Jyoti Kore to please come on stage. I also request Dr. Hitesh Singadia once again to felicitate Dr. Jyoti Kore.
Is it pointed? Pointer है? Yeah. Which way? This way? You want the laptop on there? Yeah, actually would because I want to see the slide. Yeah. Yeah, no problem. Will you give me laser pointer?
This is button, this button.
Laser pointer.
Yeah.
You can just write it. Okay. But I can't. This slide. No, we'll shut the lights. We'll close the lights. Page down is this way. Down this one.
I was from that also. This goes ahead.
Yeah. Okay, so I think we should thank Dr. Deepak Modi for setting the stage. It's a high octane energy, I can say now. So I'm going to take you. Okay, so I'm going to take you to stories actually, how the failures lead to innovations. So all college teachers and so also should look, if your experiment fails, probably you start hiding yourself from teachers. That is the first thing my students also do. But I keep telling them, unless you tell us what are the failures, you wouldn't know in which direction to proceed. And there are some, wonderful breakthroughs which actually happened because they chased the failures. Okay, so let's go over this. Like, the scientists, you can say here, they generally want to change the positive data. They want to have a clean results. They want to see significant p-values, or they want to see, okay, my experiment, I start with the hypothesis and it has to go that way. But not always it happens. Most of the time it happens that your study design is there. Dr. Purvi will also believe that, we always start with some hypothesis. Somewhere we land up, okay, this experiment is not working. Probably you need to change experiments also. I mean, the assay methodology also. So we can say that for decades, we can say the negative or unexpected data, it is always discarded. Or, like most of the time, because of the time also, we want to actually go quickly into the method which want to works. So all the innovations or breakthrough which came mainly because of the inquisitive nature of the pioneer scientists, or it just happened by chance, or some of them actually pursued failures. They had time probably, or if you have a methodical or organized way of following, this is what, so that is what has led to invention and innovations. So two such stories I have taken here, like what has led to the, you can say, father of immunotherapy or father of genetics and things. So these were the first, what was the first hint? Like something like very small. There is one Basie Rachel Elizabeth. She was this 17-year-old. Her hand got stuck during train travel. Such a simple thing. Now, can you see that entire that PD1, PDL1, CTLA for all these therapies actually evolved from here? It's just unbelievable. So that her hand got stuck, and obviously she must not have done or handle it properly. It led to inflammation. Now the cancer is actually a chronic inflammation. It's the injury which is internal, which is probably not got unnoticed. It went on, and the William Coley. Now he is the father of the immunotherapy. So what happened? He just finished his surgery degree, and he got a first case. So which was the first case? When somebody gets a first case in life, They are all excited. Okay, I'm going to treat this patient, I'm going to make this patient better. And then what happened? Failure. So what happened? Whatever his first case, it found to be round cell sarcoma, and the ear limb had to be amputated. The hand had to be amputated because she had got hurt. But there was such a dramatic in the what they say, acceleration or progression of disease, that this Basie, she faced death. So now he was worried. I mean, there was actually a picture like they're sitting. This William Coley and John Rockefeller. This also you must be knowing. John Rockefeller is the one who is a philanthropist. He actually came up with the biggest and the first institute in immunology in New York. So they were kind of sitting when the Basie died, and they were thinking, so this is the failure of his first surgery, but at the same time, this is what actually led to the innovation. So this is also, he happened that he went across the New York, he went actually walking because probably less transport. So he searched all the hospitals and what must have gone wrong. Why suddenly in just 2 months there was a death? So he found what must have happened, what must have gone wrong. So he searched and found that there is one German immigrant. So this was the report he found actually, that there was sarcoma and there were multiple surgeries because the sarcomas were near head and neck region. So you can't obviously take out everything. So he had a recurrent surgery. So what happened? He noticed that there was, because these multiple surgery, multiple skin graft, because obviously the skin had to be covered, it led to erysipelas. So these are the basically bacterial infections cause redness. Now that redness is actually, you may be knowing, that's immunological reactions. So this is what is actually led to his whatever search led to Coley's toxin. So that was what he came up with. It's a mixture of live and inactivated Streptococcus pyogenes and Serratia marcescens. These are, I hope microbiologists must be there here in the audience. So these are two kind of bacteria, and when these are gram negative. So when they are actually inactivated, their endotoxins actually cause immune response. So what he thought, okay, is that immune response is actually curbing the tumor growth. So then what he happened, he caught hold of another Italian immigrant because probably they allow you to experiment on. Okay, so it was again inoperable multiple times. He had those surgeries, non-healing nasal tonsil tumor, and then again probably people didn't allow him, so he actually did that surgery in his own apartment, patient's apartment. Obviously this will be completely banned in today's era, but that time probably he pursued, and maybe patient will say, okay, instead of dying, do something and save me. Yes, it worked. So he tried multiple injections. Again, these are part of innovations, or like what new I can do which is going to help me achieve my result. So yes, multiple injections, he tried different preparation. Now there are two bacteria. Should I add together? Should I take more of one? Whatever, different combinations. And he happened that yes, tumor regressed and patient walked disease free for 8 years. So this was a success with that. So what, of course, mechanism was not known. So again, they went ahead and found out, okay, they did some studies where they found that, okay, if the bacteria there, tumor is necrosing. Can we study the sera of those, in some animals and find what is? So that was the discovery of tumor necrotizing factor, TNF alpha, you must have heard. But of course, later on, it was realized that, of course, it was used in the as a individual single therapeutic, but as we saw, Stephen Rosenberg also, interleukin 2 was started, but later on because of pure IL-2, later on they faced toxicity studies. So even TNF alpha also faced severe toxicity. So we can say that's a double-edged sword. Okay, again, now start again with new inventions, because again the failure. So earlier there was a say success, but later again they found failure, so move on. Then this theory of infection and cancer progression, they realized that, notice that if there's a TB infection, that they have less tumor incidence or very low, no tumor incidence. So this led to development of looking, okay, can I use BCG as a therapeutic agent? Now, okay, because they found this low. So, but They of course in beginning time again they saw yes tumor regressed with BCG, but again sometimes the live attenuation of the bacteria failed somewhere in some massive school children, and actually it led to tuberculosis. So again that particular scenario got halted. But later on, again, this is that William Coley's daughter. She was actually from art side, but she, with the help of John Rockefeller, she actually supported a lot of studies on these. And later on, this Dr. Lloyd moved with, again, he tried in separate ways of whether BCG can be, tested for treatment of various leukemias, lymphomas, and other different things. And yes, he did find, yes, so what happened in 1976, one urologist, he actually got a success that intravesicular BCG can reduce superficial bladder cancer. So this is now FDA approved procedure. Even Tata Memorial Hospital has these kind of surgeries, and they do along with BCG. Now BCG has got it has got one protein in that wall, mycobacterial wall, which actually supports interleukin 1 secretion, macrophages. So it acts through that immune mechanism. So this is where you can say that was a breakthrough year 2013, and you can say it was a dawn of this whatever current immunotherapy. And the first case, so they had an anti-CTLA4, which is an immune checkpoint, PD1, which is a immune checkpoint. So they used this antibody, and the first success was seen in 2015. Jimmy Carter, which was the 39th president of US, he almost lived for 8 years. Just last year, 29 December 2024, he passed away. He almost completed 100 years. So he was the first, a success of this combination immune checkpoint therapy. And later on, of course, these the ones who got this and CTLA4, James Allison and Tasuku Honjo, they got this in 2018 Nobel Prize. So now this was the one story how different failures actually led to new invention. And currently you can see, of course, these therapies are more for hematological malignancies or melanoma, but for solid cancer, it is still ongoing, the progress. So another story you must be knowing, a lot of animal research goes on. Can you again know that how this animal research started interestingly? I mean, it is just a teacher, and I'm sure there are a lot of teachers here, and one of the teachers maybe must have lost job. So does that actually, can you think that it leads to something bestest in science, and probably the teacher will go, get sad that what happened, what can I do? But look at this teacher now. This is one teacher, Abby Lathrop. She actually lost a job because she had this pernicious anemia. Because of anemia, her health was not keeping good. So she had to lose her job because she had a legacy of teachers, means her parents, and they were teachers. But because her health was not good, she had to leave a job. But it happened that she was very, keen on doing something herself. So she went into something new. Let's call it again, so today's language will say invention or innovation, trying something new, enterprising, So she started poultry farming. Again, poultry farming kind of got, there was no success. She could see no success. But what she tried is started making fancy mice. You can see these are different color mice. So this is what she started. But while breeding these mice, so she started first with mice, then she started different animals. So she was actually not a trained scientist, but she was very methodical in writing, and she maintained breeding records and everything. So what happened then while she was writing, so at one time she had 11,000 mice in her colony, and suddenly she found some lesions on mice. Now some lesions, you will say, oh, out of 11,000 few are, I will discard. She didn't. She actually gave those to some scientists. Like, what is happening? What these lesions are? So few scientists and some collaborative scientists, I think, she is given also with some scientists so they found that these lesions are actually metastatic lesions. They are cancerous lesions. So she said, okay, why suddenly few mice are getting cancer? And this is how, so in 1902, this mice became the first to be used in a lab for genetic research. So what is happening that they are getting sensitive, susceptible to giving cancer, okay? So she was actually a businesswoman, but turned into self-made scientist. And the careful and methodical breeding actually created a current standard organism of science, that is mouse. Okay, and then she also published some, she co-authored rather with those scientists these papers. So here, so the fancy mice which she bred. So this is the one who know, this is the called William Ernst Cassel. He was a father of mammalian genetics, because at the same time this was going and he needed some animals to study what are the genetics, what are the, if you do mutations, what happens and things. So Cassel and his this undergraduate Little, this Clarence Little, he was the one who actually studied this transplantation of these spontaneous tumors in different various strains. And he's the one actually Little with they came up with concept of immunology, that is self antigen. Self antigens are not targeted, but the foreign antigens are targeted. And then he's the one who became president of this. And now Jackson Laboratories, if you are doing any animal work, everybody will know, everybody buys animals from Jackson Laboratories majorly, and he's the one who actually founded this Jackson Laboratories. Why is not going ahead? Just check. Okay. So why these animals are useful? Maybe to understand the disease biology. You can actually study the natural history of the disease. If these disease can be caused in mouse, but there are some diseases which cannot. They are not in mouse, but they are human diseases. But you cannot study in humans. So you have to check them in various strains of mice. Okay, to understand the interactions of various drugs. Now these also you cannot test in humans. If I am coming out with new drug, can I just test on any human? No, you have to have some model to study. So these animal models are used here for clinical evaluation. You can check what are the susceptibility and risk. You can also study various imaging technologies, which now you see PET-CT and other things in humans. But before it actually standardized there, they all start with mice. So, and recent advances in genetic technology have given us different mice varieties. Here I'm just giving a short, you may not go too much into it, but just to understand how it went on. So normal mouse will have a normal immune system. But can I study if the immune system is there, the tumors will not be formed? How can I study their disease progression? So this is how the inventions went on. The first was the nude mice, where this FOXN1 gene was mutated. Now you got a nude mice, so they could allow some tumor growth. Then came another, this RAG1, RAG2 are the ones which forms immunoglobulin or TCR genes. Now again, they control T cell and B cell response. So if you remove this knockout, these genes, whether you will have another variety of mice. So this way it went on. Now current strains are, so NOTSKID is what we use regularly, but the world has been using NOG, NOG, and NSG mice, where the interleukin 2 chains are mutated, and these are the different ones. I will tell you, this is how the things is. So nude mice will not have T cell because it doesn't have a thymus, but it still has B cells and NK cell and macrophages. So this is how the immunological different inventions have led to more and more things where I can have this kind of, say, NSG energy mice where hardly low macrophage activity there. So I have a better transplantation models. I can study these models well. Now going ahead, I can tell you that, so these mice are used, you can actually have a cell line derived xenograph, because now not only I want to use cell line, but I want to see different patients. There's a different heterogeneity of patients and different cancers. Can I use them and grow them as a CDX or PDX model? Can I use various drugs to check whether these drugs are useful for treating these patients in future? Okay, so these different kind of models are there in mice. And how can you choose a mouse, which model to use? That depends whether it's a metastatic growth, whether which pathway you want to study, or you want to study the drug development, or you can, whether you want to have a drug act through different pathways. So depending on what kind of model you are using, CDX, PDX, or genetic engineered, or this is the newer version. 2 minutes. So this is the newer version where humanized mice. Now I had a mouse with a mouse immune system. Now I did something invention to remove that immune system. Now I want a human immune system in that mouse to see, yes, when I add these drugs into human system, how are they going to react? Okay. So this is how, this is the NSG mice. You first but now this doesn't, because NSG has no mouse immune system. Now you add human CD34 hematopoietic stem cells that gives human immune cells. Now you add a tumor from human patient. Now you have a human patient tumor. You have a human immune system. Now study that in a humanized mice, and now you get an answer, yes, whether your drug is acting on immune profile or your drug, how it is acting through this. So these are called avatars, mouse avatars. These are all inventions, innovations from coming from failures, because something was not working. Can I come up with some answer? Okay. So this is called mouse avatar. You have a tumor transplanted from patient in humanized mice. So immune system was also same patient, tumor also from same patient. You are checking what is happening, which drug is acting. Now again give this particular drug to these patients or a set of patients. So this is the, what do you say, you can, ultimate goal is going to be humanized mice. So ATRAC is also starting this facility. And now these last two slides is what I've just given. Wilfred is here, he's a part of this. I can say I have specifically, just to maintain confidentiality, I have not mentioned much name here, but we have a collaboration with Org Therapies, and we have filed a patent for this. Like, okay, umbilical cord blood condition media is showing, you can see that this is a tumor control, and this is a beautifully, there's a tumor reduction. We also show that it acts through immune system. You can see there's, the based on the drug, the cell kill, the tumor target kill increases. But it doesn't affect. See, it kills tumor, but does it affecting your immune system? No. You can see before after, this immune profile is not changed, and it acts through this inflammasome pathway. This interleukin-1 beta is significantly reduced upon the treatment in this sera taken from mice. So this is just an invention which we have come up with. I'm proud that Caroline has been my friend since long time, and we actually came up with one science invention together. And this is my very enthusiastic team. They are very, very, they also love inventions and innovations, because it gives motivation to them to move ahead. And wonderful, even I get motivation to see young students, and if they can get into these modality. Now whenever there's a failure, please ask teacher, can we try something different, and try to find a new answer from it. Okay, thank you.
Yes, any questions?
These were stories actually, so
Anybody, any questions?
Hi.
Yeah.
Good morning, ma'am.
Yeah.
Very nice talk. It was very interesting to look at the history of immunology and how these serendipities led to such discoveries. I would like to sort of bookend today's session, like thinking of what Professor Modi said and now your ideas. Ma'am, how do you think we can use now AI in looking at immunotherapy, like the immunology data? How can we connect it with AI and sort of get these new drugs? What are your thoughts on that? Are you in looking at that at this moment?
Yeah, so I will talk pro also and against also.
Yes.
So today morning, today she read my CV as I was women speaker, selected women speaker for FIMSA. It's a Federation of Asia Pacific Immunology Society. I was only as a women speaker, distinguished. Okay, last year the thing was there. But today when I saw, do I still feature in that website? It said Dr. Jyoti Kode, president of FIMSA. I said, oh God, this AI information was incorrect. I mean, if the FIMSA president is a Japanese, if he reads this, I'm going to sure he will drop one email to me first. Because I had some interaction with him on some other aspect. So somewhere the AI actually caught those, interactions, and it just gave that Dr. Jyoti Kode is FIMSA president. So this way AI can be wrong. And second thing, no, yes, I was going to tell Dr. Deepak, AI is not good, but at the end of it, he himself agreed, not good, but you have to control. To certain extent, definitely, but finally you need a brain to devise AI modalities, whatever LLM, and you need a human brain to distinguish what will get validated and what not. So I think it's everywhere that you cannot rely, not rely, you cannot say 100% that I'm just going to follow. Today only somebody shared one WhatsApp message that those who have done the chat GPT and AI later on stop using their brain because they must be getting good information. So slowly they started enjoying, especially letters, when you write a letter to editor or something. My postdoc, he always uses this. I said, you will not use, because I take some over, not a statement, but not all. You cannot be having fancy statement always. You have to have simple, what do you say, the one, because otherwise there will not be a difference. If madam writes the same letter and if I write the same letter to editor, they are going to actually look same. So that individuality or that personalization touch also has to come. So to some extent, definitely Dr. Deepak is given one modality, one has to follow, but somewhere a personalized touch has to be there, and so that you keep using your brain and make use of. So amalgamation is required, I would say. Yeah.
Anyone else? Any questions?
And for immunotherapy, the AIML is actually, we are doing a lot of programs are being written, especially immunohistochemistry. If you have an immunohistochemistry staining pattern, what different clinical sites are giving, can I come up with scoring record? That standardization AIML is actually getting used up, and they take little time because inflamed cell and the, say for example, macrophage or neutrophil which is bigger sometimes is taken as the same. So there again human intervention is required. But yes, definitely if you use a blend of both, it's going to be wonderful actually.
Good morning, ma'am. Uh,
I
the
can't say, okay.
the presentation is very nice. I have a few. I have only one question. Since the gene therapy and immunotherapy serve as act as a same functioning, so why we prefer a immunotherapy over the gene therapy?
See, gene therapy actually requires transfection or transduction, which requires the virus associated transfers. So sometimes this is what has happened over the period. Probably if that virus comes out and turns oncogenic, what will happen? So that's the reason. And immunotherapy is something we are actually just boosting your own main immune response in whichever different format. So people are, and I think it's age-old science also, ancient science also. Yeah, though they didn't say it's a cancer, but they all had all inflammatory conditions which were tackled by ancient Ayurveda. And you can see all this surgery, even from the West world, it all started with Indian ancient science, Sushruta and all. But it went to abroad, and actually it is marked as it's a surgery procedure from West. But the main, what do you say, basic or foundation start from here, that strengthen your immunity, and you will conquer whatever. So the inflammation only will curb, so it will not proceed to cancer, because cancer is a chronic inflammation. So that modality, that's why immunotherapy is working better than gene therapy. Good question actually.
One last question, if anybody has.
Sure, sir.
Ma'am, you're talking about the immunized mice. There would be some ethical
Humanized mice.
Humanized. Okay? So there would be some ethical concerns also with regards to this, the usage and application.
We are not adding in the humans. You are taking, of course, ethical approvals are needed. Like we are taking peripheral blood, you are giving blood for testing and everything. Take out blood, add into the mouse. In 10 days, you just take regular peripheral blood cells, immune cells, add in mouse. In 10 days, it becomes a humanized mouse with PBMC. If you take CD34 cells from, say, peripheral blood stem cell harvest, or you can actually take purified CD34, add into mouse, it will become a 3 months, it will be a stable humanized mouse. And meanwhile, you can add tumor xenograft, study drug effect. So we are not adding anything out of it in the human bag. That is a ethical concern.
That's fine, but what my concern is that will it not raise ethical issues? Will it not get maybe little nasty in its immunological significance? Maybe after repeated such exposure or repeated usage. Is that particular part?
No, I have not understood question. See, you are checking in mouse because can you test new drug? If something new we don't know toxic or not, Can we test in humans? No. So you need some model to study. So we add in you mouse. I understand. Like if you want to say, I have tested in regular mouse, it showed efficacy. Okay, drug. I take in humanized mouse where it is simulating human system and we found good. There are chances that 50% it still may work in human or may not. But at least you have that 50% chance. And I'll tell you another very important. This is called co-clinical trial. Where because in human population, why many trials fail? Because there is no enrolling participant. Especially if the drug is they are targeting aging people. No aging people come forward to participate in a clinical trial. So what we do, so and this is where Dr. Deepak Modi, the AI also comes in when you do a co-clinical trial. So co-clinical trial in mice, they are done. So you can take 200 mice, test like now you know where the gene therapy part comes where I know mutated EGFR or BRAF can have a better drug response. So in mouse, you have those genetically engineered BRAF, yes, no. Now test in humanized these things and now do this using AI, how will it get connected with actual humans? So half the part is done, okay, later half. So that is faster than people do 2 and 3 years trial, but hardly one patient enrolls. What will you do? The drug may be good, but there's no trial participant enrollment. This is where the most of the drugs fail. So this is where AI and the co-clinical trials can come to help. Yeah.
Thank you.
Thank you.
Thank you so much, ma'am. I'm sure you've inspired students with your out-of-the-box insights which are there, especially in cancer diagnostics. Before we go ahead, we also encourage all the participants to interact with our speakers which are there during the breaks, tea break and lunch break. Now I would request Professor Meenakshi Vaidya to please give her insights and summarize the session.
Namaskar. I think everyone present in this room, their minds are in a tizzy. We've had two awe-inspiring lectures, each different in their own ways, but definitely making each and every one of us here present think. I'll start with the second lecture of Dr. Jyoti Kode. And she started with think out of the box. I think the thinking began there itself. And the inspiring stories that she narrated. You know, I'm a great fan of our former president, late Shri APJ Abdul Kalam. And in one of his quotes, I quote, FAIL stands for not failure, but first attempt in learning, unquote. And I don't think there is anything more apt than the stories that she told us that how we should not give up and how we should think in a slightly different manner so that we could have some new idea. The story about Abby and up to the immunodeficient mice or even the humanized mouse. I think we have really a long journey ahead. And who else could be better than the young lot sitting in front here? And I am sure someday one of you would be telling your story to somebody else. The subject that I fear the most, computers. And believe me when I tell you this, that I actually did one finger typing of my thesis. Okay, so but when it comes to certain things that are mandatory, you ask 10 people, chew their brains, and then you start doing it on your own. I'm sure Hitesh here will endorse it that we've learned so many things. And I think Dr. Deepak Modi, Professor Deepak Modi, has, given us insights as to why artificial intelligence today
Hi,
is
Saurabh.
important.
Can you
And,
turn on your video?
right from the
Technically, you want to just
modern
check the feed and
laboratories,
everything.
which are going to be equipped with these sort of things,
Hi, brother. Can you see my video?
we have to be
I can't.
smart scientists.
Okay, give me 1 second.
Not only that,
Sure.
I'm sure all, as most of you raised your hands, sorry, I saw you all raise your hands when he asked how many of you use Chat GPT and all that. But
Yes,
yes,
absolutely.
it is the need of the hour. But
Okay.
I don't
Let
think
me
you
check with
should
my
stop
team
there.
if they can give me a
And
go
that's
ahead.
what he also said in the end. We have to do this machine learning, deep learning, and use these LLMs sometime or the other. Maybe not directly, but through somebody else. But at the end of the day, we need to remember that the human brain is paramount. And they have given us a lot to think about. I have said this a couple of times, that we think we know a lot and we always come with the glass full, that, okay, I know everything. But still, there is that scope, to put that 1 spoon of sugar and stir it a bit and make it a little more sweet. Learning is like that. And I have a lot of food for thought because of my own fears. But yes, I will definitely think and try to take that first step towards artificial intelligence. Thank you. Thank you very much.
I would request Dr. Hitesh Singaria to please thank ma'am with a small token of our love.
Yes, ma'am. It is at home, it is in house, but then still the formality is please. This is small token of appreciation from RYI.
I now request Dr. Mayuresh Joshi from KC College, our RYIM collaborator, to please felicitate Dr. Papya Deb and thank her from our side. Ma'am, please. Ma'am, please.
Just one single sentence. After hearing both these talks, I mean, it was immensely inspiring. There are very few speakers who can inspire and inform at the same time. I suppose both of you, Dr. Modi and Dr. Kode, you all have done that work. Thank you so much. I suppose the students over here, they are too excited to know more about whatever you have spoken. Thank you so much.
Thank you, Meenakshi ma'am. Thank you, Papya ma'am. Now we continue with our next speaker, which is going to be an online session. We request everyone to be seated yet. Just one more session, after which we will have our tea break. So just 2 more minutes while we do the setup. Please be seated.
You're starting with 24. Yeah, you're going to be live in 1 minute. Okay. Will I be able to hear the intro and know when
You
to
will
start?
be able to hear, yes.
Dr.
Yes,
Yes,
Saurabh
yes, you will be able to
Gupta,
hear.
a proud alumnus of Mithibai College, currently serves as the
Currently
Associate
serves
Director
as
for
the
Global
Associate
Medical
Director for
Information
Global
and
Medical Information
Communication
and
at
Communication
AstraZeneca.
at AstraZeneca.
In his leadership role,
In his
he
leadership
develops
role,
scientific
he developed
communication
scientific
strategies for
communication
innovative medicines,
strategies for innovative
ensuring that
medicine,
complex data
ensuring
is
that complex
translated
data
into
is
clear,
translated into
accurate, and
clear,
meaningful
accurate,
insights
and meaningful
for
insights
clinicians,
for
researchers,
clinicians,
and patient
researchers,
communities.
and patient communities.
Dr. Bandhavkar
Dr.
completed his
Bhagat
PhD in
completed his
neuroscience in
PhD in
Australia,
neuroscience in
where he
Australia,
distinguished
where he
himself both
distinguished
as a
himself
researcher
both
and
as
as
a
a
researcher
communicator.
and as a
His
communicator.
contributions
His
earned him major
contribution
honors, including the Australian Neuroscience Society's Outstanding Early Career Researcher
only
Award
career researcher
and
award
the Dean's Award for
and
an
the Dean's
outstanding
Award for an
PhD thesis.
outstanding PhD thesis.
He has also received
He has
multiple
also
accolades
received
for
multiple
excellence in
accolades for
scientific
excellence in
communication,
scientific
winning
communication,
Best Oral
winning
and Poster
Best Oral
Presentation
and
Award,
Poster Presentation
as well as
Award,
the People's
as
Choice
well as the
Award for
People's
delivering
Choice
a
Award for
compelling
delivering
3-minute thesis
compelling 3-minute
to a
thesis
non-scientific
to a
audience.
non-scientific audience.
Today, Dr. Bandhavkar
Today,
will
Dr.
speak on
Pandavkar will
scientific
speak on
communication and
scientific
leadership beyond the
communication
lab.
and leadership beyond the lab.
We please welcome Dr.
We please
Bandhavkar
welcome Dr.
online.
Pandavkar online.
We are trying to connect the
We're
time
trying to
difference.
connect the time difference.
So just give us a few more
So just
seconds
give us a
and
few
everybody
more
can have a little
seconds
more
and everybody can have a
patience.
little more
I know
patience.
you're very excited
I
to
know
hear
you're very
some more
excited to hear some
wonderful
more,
insights,
wonderful
and you're
insights.
very excited to
And you're
start the
very
research
excited to
now you're
start the
having.
research now you're having. Just a minute, we are getting the feed on.
Okay, so before we begin, I would request Dr. Kanti Kiran and Dr. Mayuresh Joshi, our RYM collaborators, to please chair this session.
Father. Can you see the audience? Yes, I can see people. What? Fantastic. Can I start? Just a sec, just a sec. Okay. Technically needed, the team needed to confirm something, that's why. Yep, you're on the screen now. Hello, everyone. Hopefully, you can hear me and see my presentation. Thank you so much for the kind. Saurabh, wait. Saurabh, wait.
Good enough to you and you are to us.
Saurabh, wait. Okay. Just a second, Saurabh.
Yes. Dr. Saurabh, can you hear us?
Yes, I can.
Yes. Please, the stage is all yours. Thank you.
Perfect. Thank you so much. Hopefully, you can hear me properly and can also see my slides. Thank you so much for the kind introduction, and thank you so much for the opportunity to actually present at this session as well. I'm deeply honored. Having looked through the agenda myself, I feel a bit unfortunate and I'm having a bit of fear of missing out right now that I couldn't be there in person and listen to all the other sessions which look very exciting, but hopefully some other time. Today I'll be talking a bit about scientific communication and leadership beyond the lab. But before I go into my talk, I really wanted to start with just giving a disclaimer that the views and opinions expressed in this presentation are my own and not necessarily reflect those of AstraZeneca. I also wanted to just give a quick background about my education profile just to set the scene up. As mentioned, I did my Bachelor's of Science in Biochemistry from Mithibai and then also Masters of Science eventually in India. After completing my Bachelor's and Masters of Science, I moved to Australia to do my PhD or Doctor of Philosophy, which I did in neuroscience. Currently, I work as an associate director in Toronto for our global medical information and communications team, and I also look after the vaccines and infection team. Now, when I reflect back on my journey, it's somewhere very difficult to say, but it's not my scientific skills that really took me from where I was to where I am right now. It was not the experiments I did or the models that I used and the findings that I had that led me to have a very successful career. In all honesty, when I reflect back now, what really mattered in my journey was how I communicated my findings, how I used communication to leverage opportunities, and also how I demonstrated my leadership skills along the journey when I was doing my PhD in academia and also when I transitioned into pharma. And hopefully today I would like to share some of the learnings that I had along my journey around how important communication is, how important leadership skills are in scientific career, and hopefully that inspires you to also take it back to your careers and apply it in your day-to-day life as well. I don't think I need to tell this audience how important communication is in science. In fact, Sir Mark Walpole once said, science is not finished until it is communicated. And how true is that? Because communication is basically the key for science. Publications are equivalent to academic currency. If you don't publish science and if you don't communicate science, the world will not know what you're doing. Similarly, it's very important to communicate your science at conferences, at seminars like these, so that the visibility of your research or your science gets more impact out there. And lastly, communication is so important when it comes to writing grants or when securing funding as well. So communication is really key when it comes to science. But one of the biggest turning points in my career when I understood how important communication is was when I had the opportunity to attend a seminar from the editor of the journal Cell. For those of you who don't know, Cell is one of the top tier journals in academia and in science. It has an impact factor of 41, and people really want their articles to be published in Cell. And I had the opportunity to attend the seminar, which was given by the editor of Cell. And I had an eureka moment at that time because he said, the statement, science is not truly finished until it is communicated, is incomplete. It does not really encapsulate what really needs to happen. And he said, science is not truly finished until it is communicated clearly and effectively. And that was really my eureka moment because until then, I had really not understood the impact of clear and effective communication. I always felt, okay, I spoke about my science and that's it. That's great. But it was more about clearly and effectively communicating science. That was really the most important key that I learned through this talk. And since then, I've really tried to make sure that my communications moving forward are clear and effective. It also allowed me to understand that communication is not just a soft skill, it's actually a career multiplier, which not only helps you in securing funding and boosting the visibility of your research, but really also helps in building collaborations and enables leadership at any career stage. And this is more relevant now than it was ever. Because in the modern world that we are in currently, science is no longer isolated. Today, scientists have to really communicate with diverse kind of stakeholders. Scientists speak to clinicians, scientists speak to investors, scientists speak to policymakers, to cross-functional industry teams as well. And effective and clear communication with these stakeholders and influencing them determines how impactful your career would be in science or outside science. And understanding what is relevant to the target audience and adapting your conversations accordingly is most important when dealing with communication. Let me give an example. For example, it's very important to understand what your target audience is, what they care about, and how to adopt your communication styles when speaking to them. If you're speaking to a clinician, the patient outcomes are the most important things for the clinician to know about. And it's very important to adapt your conversation so that you talk about the clinical relevance of the data first when speaking to clinicians. When you're speaking to regulators, it's important to understand that the safety and mechanism of action of the drug, of the study, is most important to them. And how to adapt your conversation is by talking precisely about standard deviations, about the relative risk ratios, about the standard errors, and documenting everything properly because the regulators really want to see all of that in your communication, be it verbal or written. If you're speaking to industry teams, strategy and feasibility is what they care about the most. And at that time, it's important to communicate in such a way where you're tying science to business. And lastly, when you're speaking to public or patients, it's important to speak about the meaning and benefit. So simplify your conversations with these people and avoid the use of acronyms. I'll give one specific example in the case of a clinical trial. Let's assume that drug Y was uh, read out in phase 3 study, and the results found out that drug Y reduced annual asthma exacerbations by 55% compared with placebo. So having a conversation about this phase 3 study with a clinician, the conversation would look something like, in the phase 3 trial, drug Y reduces asthma exacerbations by 55%, with benefits observed across eosinophil levels. Patients also reported fewer hospital visits and improved symptom control within 12 weeks. You keep it crisp, you tell them what the patient's outcomes looked like from the phase 3 trial, and highlight this in your conversations with them. Similarly, if I was talking about this data with the public out there, I would use a very different way of communicating with them. For example, I would say something like, in a major international study, patients taking the new asthma treatment had their severe attacks cut by more than half. Many were able to breathe more easily and avoid emergency visits. I hope you can see the difference between the two statements and how important it is to actually flex the two statements to communicate based on who the target audience is. And this is something I really want you guys to understand because it will help in your careers when you're talking to people. So, how to improve your communication skills? There are a few things that I did during my research career, which I really want to share with you guys. Firstly, I really joined a lot of seminars, journal clubs, and put my hand up often to present. This really allowed me to improve my scientific communication skills. I also attended translational research discussions, industry talks, and regulatory sessions. This really helped me to understand how do I have conversations with industry people, how do I have conversations with regulatory bodies, and also how to discuss and analyze translational research. One of the tips that I would like to give you guys is always keep your elevator pitch ready. Elevator pitch is how will you describe your research or your science in just a minute if you get a chance to be with someone in the elevator. So make sure you practice that because that will be very handy. The third thing that I did was participated in scientific communications such as 3-minute thesis or some university science communication events. These competitions it, were planned and designed in such a way that you have to speak about your research to a public audience. And participating in these competitions really allowed me to understand how do I take out the scientific jargon and speak what is really important for the patient or for the public and communicate accordingly. Other thing that I did was I always kept speaking to my non-scientific friends and telling them what my research was all about. The day when I was able to explain it to my non-scientific friends exactly what I was doing in my research without using scientific jargon, I realized that okay, I was getting good at communication. And I would highly advise you guys to do that because your friends will also give you appropriate feedback that you can work upon. And lastly, one of the most important skills about communication, which does not get spoken about a lot, is active listening. Listen to how your leaders are communicating, how clinicians are communicating, how industry teams are communicating, and try to adapt your style to how they are communicating, because that will really help you to build relationships with them, build network with them, and eventually leverage those relationships to propel in your career. And this brings me to one of the most important things about communication, which is leadership. Great leadership is nothing but great communication, and they both really go hand in hand. But there are a few things that I really learned along my journey, which are important from a leadership perspective. Firstly, I want to say that the most important thing that I learned was that leadership was not about having a title. It was about your behavior and living that behavior day in and day out. So don't think that, okay, I'll show leadership when I'm the vice principal of the university or when I'm an associate director or when I'm a director. Start thinking about yourself as a leader from now. Behave like one, live like one, and take it forward because that's how people will notice you as a leader as well. So, there are some leadership essentials that I would like to highlight from an early career research perspective. The first thing is that leaders really have a big vision and curiosity. They have their eyes focused on the bigger picture. They're not just thinking about the experiment in hand, they're also thinking about how this experiment impacts the whole narrative of the research, what to do, what not to do, and they have that vision very clearly in their head. They're also people who are very curious, who ask questions and challenge assumptions. And in my research journey, I try to make sure that I focus on having my vision on the bigger picture and be curious. So I advise you to do that as well. The second important thing about leadership is building collaborations and network. Believe me when I say this, meaningful relationships will really help you go forward in your career, be it across labs, institutions, disciplines, and industries. So embrace teamwork and really respect diverse perspectives. I want you guys to always remember that leaders always collaborate, they never compete. So don't be lost in competing with others. Focus more on collaborating with others and how everyone can succeed together, because that will be really helpful in your career. Lastly, seek mentorship from people who are above you and have a growth mindset, because leaders always think about developing skills, be it technical skills, managerial skills, and personal skills. And one of the last things about leadership, which I spoke about even at the start, is great leadership is nothing but great communication. So, how to communicate with a leader and like a leader? There are two things that I do always when I have to communicate with a leader or like a leader. The first thing is to start with why. There is also a book by Simon Sinek, which I recommend reading if you haven't read this already, which is called Start with Why. And the whole book talks about the philosophy that people don't follow you because of what you do, but why you do it. If your purpose is very clear, then people will resonate with that purpose and follow you on that. So when you're communicating with a leader, or if you want to communicate like a leader, always start with why you're doing something, because people will resonate with those emotions. You're speaking with leaders or when you're talking like a leader, always speak about the situation first, describe the situation or challenge you faced, then describe or explain the task and your responsibility, then go on to the actions that you took to accomplish the task, and then share how you achieved that outcome and impact with your actions. And this STAR framework really helps the other person understand and get the whole picture of what you're talking about, and there is clarity on their end. And when there is clarity on their end, they are really influenced easily by what you're saying. So please make sure that you follow these two philosophies, which really helped me in my life. First, start with why, and second, use the STAR framework in your communications. I do want to call out this, that your leadership will really rise or fall based on your ability to communicate. So don't take communication for granted. I want to end, no, I want to highlight a few things that early career researchers can do to really showcase their leadership or enhance their leadership skills, which I as well did. Own small projects. Speak to your principal supervisors, speak to your managers, and see if there are opportunities to start small projects, small research projects. Maybe there's a research question that needs answering, which is a small project. Try to take leadership on those projects. Try to find opportunities to bring teams together, like organizing seminars or symposiums like this at department level or institute level. Ask great questions, be curious, challenge assumptions, and showcase that you are thinking out loud. Get opportunities to mentor and tutor your juniors. If you're a senior early career researcher, then please reach out to the junior early career researchers, guide them, mentor them, and tutor them, because it will also help you to hone your leadership skills. Lead journal clubs, organize them, lead them, make sure that you communicate well in these journal clubs, because this will really allow you to develop your communication skills as well as leadership skills. And lastly, drive culture and collaboration in your lab, in your institute, or at a department level. Organize networking events, meet and greet events, fun events to support diversity and inclusion. Participate and lead a student committee. And there are many other examples that I can give to drive culture and collaboration. Do some of these activities, because this will really help you to actually propel your career and showcase your leadership when you're applying for jobs outside of your own department or your institute, or maybe even outside of academia. I want to end with just one simple note, that a leader is someone who knows the way, goes the way, and shows the way. Hopefully, some of these learnings will help you as well. But if you have any questions, I'll be happy to take them now.
Do you have any questions? Do we have any questions, please? Ivan, thank you so much for this enlightening talk. It's very, proud moment for us that our alumnus, our ex-student is, giving a talk over here, inspiring the younger generation that is there. So thank you so much. I request Kiran ma'am to please come and summarize the session.
Thank you, Dr. Saurabh, for this lecture. I think most of the students here might have benefited out of it because they're looking forward and they will be stepping forward in next few years to go through all this. So thank you. But I'll just say that he talked about communication and leadership, which is obviously very, very essential. For me, what is important is that communication it starts at home. A child starts it at home with sign languages and then understanding the language and speaking the language, what their family uses. It's like the mother tongue. And then the professional language, which basically is English in profession, but otherwise, even for major cities like maybe Maharashtra, Marathi, for Gujarat, Gujarati, for UP and North side, Hindi, and so on. So that is very important. But what we do is we try to, misdirect ourselves and use a lot of common slangs, common words which are not very useful because that is a little more convenient for us and it looks cool, for especially for Gen Z. Now the language is very different than what we used to in 90s and before that. Obviously, this is a scientific session, so we are more talking about professional language that needs to be inherited within you to grow. So that is obviously that you should be absolutely clear in what you want to say. Be very precise. You do not have to, elaborate, have fancy sentences. Be very clear and very simple, which is what he emphasized on. Very good. And also for the leadership that you have to bring your team together. So if you're having a team of 10 people and you're leading that, you're having people who thinks on the same point with a different perspective, which is possible. 10 minds can think in different 10 ways and still, end up in one single outcome. And where the role of leader comes in, you have to incorporate everything, understand the perspective of every person, whether the way is different or not, and then think which can lead to your destination or your end product in less amount of time with more clarity and just keeping everybody together. So it's not dictating, it's being together. A leader will never be successful single-handedly. Obviously, the team works very hard and then the works gets successful or the your publication or anything, your scientific project gets success. So obviously, for being communicating as well as being a leader, you need to have a purpose and a very clear purpose. Be very simple, have very simple language, have very accommodating nature if you're leading. So this is what I'll say. It was very nice and very clear, Dr. Saurabh. Thank you. Thank you, ma'am. I request Mr. Manish Gogri, Vice Principal, Mithibai College, UG Academics, to please state thank you, ma'am, with small vote of thanks. Now request Dr. Sharon D'Souza to please, felicitate Mahesh Joshi sir with a small token of honor. Thank you so much. Now we break for tea for 10 minutes. We encourage the participants to please interact with the speakers, to
Hello, mic check. Hello, mic check. 1 2 3, 1 2 3, mic check. नहीं नहीं भाग क्यों रहे हो जब कुछ कर रहे हैं तो सीधा बोलना था Hello, mic check. 1 2 3, 1 2 3, mic check.
Requesting everyone to settle down, please. We begin with the next session. Our next speaker is Dr. Shuli Mitra, Director, India Bioscience. Dr. Mitra transitioned from a career in research to science communication 8 years ago. As a communication specialist, she has experience crafting impactful narratives for science organizations in government and academia. Her work has ranged from content development across diverse media to formulating external and internal communication strategies and advising senior management on public communication of science and technology. In the past, Dr. Shuli Mitra has worked with BRIC, Translational Health Science and Technology Institute, Faridabad, the Office of the Principal Scientific Advisor to the Government of India, the Archives at Christian Medical College, Vellore, and DBT Wellcome Trust India Alliance. She has a PhD in anthropology from the University of Delhi and was a postdoctoral fellow at CSIR Center for Cellular and Molecular Biology. We welcome Dr. Shuli Mitra, please. All yours, ma'am. Thank you so much.
Thank you, Shauri. Okay. Is better? Everybody in the last row can hear me, as long as that's my. until we get that set. By the show of hands, how many people had heard of India Bioscience before the announcements for RYM were made? Ma'am is not sure whether it's you are. Okay. 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 So the purpose of my talk would be to just have everybody raise their hands in a yes. Okay. I can also move the slides myself. Okay. So India Bioscience is a national science program which is based in Bangalore, but is pan-India in its presence and action. What we do is very ambitious. We have a long list of activities, many partners that we work with, but essentially what we focus on doing is changing the culture and practice of science in India. So that is our guiding mission. I am going to talk to you about who we are, a little bit more about who we are, what we do, and what is it, how can you engage with India Bioscience in the next 15-20 minutes. But before that, I'll tell you about how this came about, how the organization came about, exactly why, continuing with the story from yesterday about how RYIM Mumbai was planned. So it was a very similar young investigators meeting that happened in 2009 at Thiruvananthapuram, ISER. And a group of young investigators who attended the meeting came together and noticed that there is very limited space for young investigators to come together and talk to each other, share about what their problems are, what should be the purpose of them working with each other, the visibility of the research that they do. That hugely impacts funding, because when it comes to funding, yes, it's working now, thanks. When it comes to funding, the decisions are mostly made in pockets in the country. So researchers at every stage of career, from every geographical location of the country, require that visibility. So those discussions about the need of that kind of space is what led to the creation of the organization. So India Bioscience has actually is one of those outcomes of a conversation, of a meeting like this. What happened after that is there was an American biochemist, most of you might know his name, Ron Whale, who is also one of our board members now, was a part of the meeting and proposed that we have an organization which creates a platform, and for all of these young investigators from across the country, from outside India, who want to move back to the country, to come together and work with each other. So the conversation that was initiated by Ron Whale was just, it just gave an impetus. But what carried forward for the next 6 years was a result of the persistence of this community of young investigators who mostly, worked in Bangalore, located both in and outside of Bangalore, found a space at NSPS and kept the organization going. The website that we have right now was created in 2010, has undergone updates, of course. Then they continued with a lot of enthusiasm for the next 6 years. And it's only in 2013, 2014 that when other funding agencies started recognizing the need of an organization like this, and that is when we had our funding from Department of Biotechnology, which still continues. So this, we are actually ending the third cycle of funding from DBT and stepping into the fourth cycle of funding from them. And we are hoping to now diversify the set of activities that we do and deepen the reach within the country. So we have a very small team of people who work for the organization. And most of you, I think, in the organizing committee would have met Momita. While the team itself is quite young, not me, rest of the people are quite young, we have very senior scientists who are trained across India and globally, lead different institutions, advising us on strategy. We are primarily, as I said, funded by DBT, but over the years, we have also received very generous funding from global organizations, and which has also helped not only expand the impact that we have, but also strategically change what we do. So how we see ourselves is somebody who catalyzes the culture and science and practice of science in India. We also, after that, facilitate different networks that are built through these initiatives. And what helps that is continuous engagement outside of academia, through industry, through policymakers, through policymaking bodies, both within industry and within government. Our primary target groups, of course, is sitting over here in this room, both researchers and very little research professionals, students, educators. And what we do is broadly falls into creating networks for them to collaborate with each other, to find mentors among each other, bring visibility to the research that happens in Indian labs by researchers who work in the country, support different science careers and not just academic, and engage and help researchers across the career stages engage in development of policy. I'll delve a little bit about how we promote network in building networks and creating collaborations. Meetings like this help people meet each other. And once people meet each other, which usually, translates after long email conversations, WhatsApp texts, when something like an in-person meeting happens, people get to understand what their strengths are. What is it that one person or one institution lacks that they can find in another person or another institution? And that is how these collaborations, these networks are built. Once you have attended a meeting like an RYIM, you have become a part of that growing network of people, where you will find researchers, where you'll find science educators, where you will find research professionals who have chosen careers outside of academia. Developing mentorship skills is something that has been particularly important for people who have joined these networks. We do not think mentorship always happens top down. There is a lot of mentoring that one gets from their mentor. I think if you sit along with a group of other people who is in your batch, you will find a lot more ideas. You will spend a lot more time. You will find a lot more acceptance when you are having those very difficult, sticky conversations. So this many collaborations emanate from that comfortable space, from that safe space. And I think India Bioscience has been able to create those safe spaces, just hold those spaces for people to come together and have those conversations. We are right now preparing for our next annual Young Investigators meeting. We will be having 40 young investigators from across the country. Young investigators are those people who are in the first 8 to 10 years of starting their independent research groups. All of our co-organizers for this meeting and many others in the room are YIs. Some of them are our alumni who attended the meeting this year. And what happens at these meetings is people find their future partners, future collaborators, mentors, because people who attend these meetings come from funding agencies, come from industry, come from different career stages, and come as mentors, irrespective of the career stage that they are in. If they have a certain skill set that young investigators and postdoctoral fellows lack, or have a knowledge about, how the scientific ecosystem in India works, they are recognized as a mentor. So the last 2 days of the meeting are particularly important for postdoctoral fellows who are looking for jobs in Indian labs. So what we do is we invite institutional leaders to come to the meeting, talk about their research program, and it helps postdoctoral fellows to understand the diversity of research programs, also get to know institutions which are hiring, and then also meet the recruiters' specific needs. Whenever there is faculty hiring process going on, people would be looking for a piece of the puzzle to be, to come together. So these meetings help prospective applicants meet the recruiters. Coming to the regional young investigator meetings, one of which that you are a part of, we have had them across the country. And I think not many state-funded colleges have been applicants, and which is why, the proposal from Mithibai really stood out. And it has been immensely gratifying to know that there's a huge network of science educators which are joining the India Bioscience Committee through this program. They are mostly young investigator driven, and that is by design, because a young investigators in their first 10 years is extremely challenging, because that is when they turn mentors for students. They have to find funding, and then they are also given administrative responsibilities for the first time. So the RYM is designed in a way for them to challenge themselves and find a way to just have that meeting. And congratulations on getting it done, Sharon. She does, yeah. So there has been a lot of interest from your teams over here to apply for science outreach grants. We are going to announce the next one in June, July next year. Please make note of that and do apply. For everyone else who is thinking about what it is, so India Bioscience funds gives very small funding, a seed funding for people who are looking for science outreach initiatives. Science outreach is essentially designed to take your science outside of your lab. This could be for a policymaker. This could be for making your innovation is more visible. This could be to work with a community that is suffering from some nutritional deficiency. The purpose of that is decided by you. The audience is decided by the young investigator, but they are also mandated to look beyond their own research labs and find partners who are experts in engagement, in community engagement, in engaging with industry, in engaging with policymakers. And these are collaborators who we don't usually find within our organizations. So this is by design, this is made to push your boundaries and find those people who would partner with you and make your project much more meaningful for the target audience that you are reaching out to. So we have been able to create a database of life science researchers from across the country through different initiatives that we have had over years. It's a very small database right now, but if you have a research project, if you are looking to partner in a specific area, what you essentially need to do is to log into the website and just type in the research area. You will have a list of researchers working at different institutions in the country. This is a database which we plan to expand in its reach, but definitely look at it if you are looking to collaborate with people from other regions of the country working at other institutions. We have also been using the India Bioscience website to make the research that happens at Indian labs more visible. As you saw, we don't have a very big team, but the number of articles that we have every year goes beyond 100. How that happens is the person in the team gives an editorial oversight, but the pitches, the articles for articles and columns, podcasts, and others come from young writers and others across the country. If you have a science story to tell more people, then you send us a pitch, and it goes through an editorial review and it gets accepted. But if you're also getting started as a writer, what you'd also get is mentorship, very specific mentorship. The pitch might get rejected if it's not at a level that is acceptable for the website, but you will definitely, the team member will definitely spend time to train you to write a better science story next time. And that has actually helped us get stories from across labs, but also from researchers, about the research of people whose research would not be covered by national dailies. So it's been very important that way. We have also been able to, and that's the story of how Sharon became a young investigator. So we have these journey of young investigators going on for the last several years, and we have been able to document stories of many young investigators who joined the community, for others to not just get inspired by those stories, but also understand a little bit closely about what are the challenges that you can expect when you enter the life science ecosystem, when you make the decision of becoming a young investigator. And I think what is especially comfortable to know is that you are not going to be alone who's facing that challenge. So when you listen to these stories, you should also have it at the back of your mind that there are many others who are going through challenges. Just read those stories closely and maybe reach out to people whose stories are being told, and just help. That interaction might help you understand how they went about that challenge. The Resilience and Representation in Research is a very new series, but it actually was born out of an event that happened at IIT Bombay last year. So a group of women researchers came together to have conversations about the problem of gender equity in hiring at institutions, at science institutions specifically, and other areas of research. And that has been affecting women more. And what we were able to do through these series are bring those voices together to help other women in research understand what are the challenges they can expect, and who are the people that they can reach out to if they want just a year to hear them out. We have also received over the years many opinion pieces by people who work in policy, people who watch policy development very closely, sharing their views about what are the different challenges of policy formulation also, and then final implementation. these again, these are pitches that are sent by both who are involved in the policy formulation and those who are affected by it. So how you can contribute is creating resources which are, columns, articles. If you want to organize a grant writing workshop, for example, or be a part of one, you can write to us with pitching the idea of an informational webinar. What we can do is connect you with mentors from different funding agencies who would be able to tell you about the application process, but who would also tell you about what gets an application accepted and what gets it rejected. Okay, and these kind of webinars, these are also webinars, but these are also in-person workshops that we are right now thinking about. So this is something that I already told you. Just I'll also share the email ID where you can send that pitch later. So the European Molecular Biology Organization has been very generous supporting the regional young investigator meetings and the annual young investigator meetings by sending EMBO members who work across institutions in the country. They send EMBO members who come for the global lecture series talks for these meetings. I know there hasn't been one in this meeting, but if you get to apply for the next meeting, which is at ISA Tirupati, I think you will have one person over there. They also organize informational webinars for young investigators to apply for their fellowships. And the next one is actually happening on 8th of December. They have a travel grant for postdoctoral fellows to go to labs in Germany and work for a very short period. And if you are interested to apply for that, definitely attend this webinar. If you are not able to attend it on 8th, what you can do is just watch the webinar on our YouTube after that. How else you can engage is we have a Crafting Your Career workshop later today. But what we also do is outside of regional meetings, we have these workshops whenever an institution invites us to have them. The purpose of this workshop is to tell people about science careers, both in academia and beyond it, and generally how to make important critical decisions about at different stages of your career path. The networks that we have built over years has also helped us keep connected with researchers as they turn middle career, senior career from starting with in the first few years of their career in India. And since we have been connected with them, we also get to hear very closely how they are getting, how their own perspectives about mentorship, about science funding are changing over the years. So all of those people who are connected to this network also help us understand what is the pulse of this community as we, look at changes in science funding, look at experience policy changes. So we keep our ears, we are very attentive to how community voices are changing, and then it becomes also a responsibility to give space for those voices to reach people who are at a decision-making position. So you will, as a part of this network, don't be surprised when we send you surveys to respond to us, and I hope you find time to respond to those surveys. So we also, people who are looking for jobs, I would suggest that you subscribe to the newsletter, the jobs newsletter. We are sent advertisements by institutions who are looking to hire both research and non-research positions within institutions, and we have a newsletter that is dedicated for that. These are social media channels, and that would be it. Thank you so much for your attention. Any questions for me?
Are there any questions?
There should be, because it's an opportunity for you all to network further. Next, probably RYIM can be somewhere else in Mumbai or somewhere else around Mumbai.
I think they need it for the YouTube live.
Can you explain a bit more about this IOG, Science Outreach Activity?
Yes.
Do you expect it to be college students or school children can be? I mean, if I am writing that project, can the school be part of it?
Yeah. So, India Bioscience Outreach Grants is open for application to young investigators. Young investigator is someone who is in the first 8 to 10 years of their research, of starting an independent research group in India. Okay. The co-applicants, one of the co-applicants has to be definitely an engagement practitioner who understands community engagement. And there can be other young investigators who are part of that applicant team. I think your question is about the target audience. Who can be the target audience? If you have a good question in your application, you just need to justify who your audience is. What we prefer, since these are outreach grants, they should be, the intended audience should be outside of your research lab. It could be college students, but there has to be a clear purpose of that. It could be school students. There have been audiences of target audiences, target groups of people living with disabilities. There have been the spectrum of target groups that have been covered through these grants have been, just very far and wide. But as long as you can justify that, it could be anyone else.
Yeah, so while the others think of the next steps and questions, my question to you is that India Bioscience, I think I saw the scientific communication landscape evolve once India Bioscience came together. It became this meeting point for all kinds of job opportunities, research collaborations. Now, it's one of the pioneering organizations, but the scientific community is very large, and I know many have interests in getting into research management and communication. So other than your organization, which I'm sure everybody is going to eagerly apply to after this, what other avenues are there or institutions are there that promote these kind of roles? And if you could sort of give us an overview of the path to such positions in government and private institutions.
You have to come for the workshop, Anusuya. I cannot just be giving you information without you coming
That
for the
is
workshop.
true. That is for the
But,
workshop.
talking about other platforms, we do understand that the community itself is also growing. When we started in 2009, I think the reach was quite limited, but it has grown over time. I think the reach, there is a lot of scope for us to also reach into deeper pockets in tier 2, tier 3, which is where we have been limited. The idea is to now turn the table and ask the community also take the onus upon themselves and help us grow the reach of this organization. So if you know about the initiatives at India Bioscience, you are, as a part of this network, you don't need anybody's permission to talk about the programs. If you want to organize a science careers workshop, go ahead and do that. We will give you the material and the support that you need. Okay.
Okay, thank you.
So yeah.
Last question, please. Anybody?
I'm going to talk to them for 3 hours, so I think it's okay.
Yes, I think we've got a lot of information right now.
Interact with you in absence much more.
Yes. Thank you.
Thank you, Dr. Julie, for this very inspiring and interesting talk. I'm sure the students have a lot of queries, but that will happen in the CYC workshop and in the other session. Yes. They are very shy. The teachers are sitting right here, so they have to, tread very carefully. Now we move on to our Askers Anything session, and I would request Dr. Modi, Dr. Kode, Dr. Kanti, Dr. Shivli, Dr. Hitesh Singaria, Dr. Mayuresh, and Dr. Sharon to please grace the stage.
एक जन वो स्टैंड पे खड़ा रहेगा, एक जन इस स्टैंड पे खड़ा रहेगा, दोनों के हाथ में माइक होना चाहिए, जिसके के हाथ में दे देना। जाओ।
Yes, sir. Papia? Dr. Papia? Dr. Papia? Join us. Come.
मैं देख के आती हूँ, तू इधर बैठ भाई, तू इधर से। Yes. So we start with the Ask Us Anything session. So whatever queries, questions you have, please feel free to ask the entire panel that is sitting here. This is yes. It started. Yes, ma'am, please. Can someone just hand over the mic?
One request, before you ask your question, just introduce yourself so we need to know whom we are interacting with.
Hello everyone, I'm Dr. Neelam Dabaskan, Ramalinga Swami Fellow at JNU. And my question is, it's a very generic question. We talk a lot about work-life balance as scientists. And I would like to hear from you, what are your comments about it, or how can we improve that balance?
I can talk about it because I am myself a woman and I know that while pursuing our passion, first, if you give importance to everything your own self, others will give importance. But then you have to be very true to your own self. Okay, today I need to be at the institute. Maybe if there's a conference, I may be there longer time. But at the same time, if I have something very, not the same day, but any other days also, whenever something important at the home, you have to give importance there also. So at both places, they come to know, yes, though at times she has to go, but she has been genuine, sincere in her work also during her work hours. So I think this way you can manage, and this is how you actually learn multitasking. I feel women, I shouldn't say, but women are more multitasking efficiently because they give more attention to family also and work also. Not that men don't, but somehow when they are at work, they will focus more at work only because they are assured that, woman at home will take care of the family. But when it comes to women, my half the time, even if my daughter is in Germany and she needs some urgent call, I ask her, or even they have trained now. Are you in very busy? Then they will keep the call. But if she has something, she says, like, say, okay, no, this is something 2 minute urgent, I give time to her also. So I think in this way we kind of proceed, may not be in a high speed, but we are managing everything in a balanced way, is my opinion. I think others can also, probably Siuli can also talk about it. Yeah.
Okay, I'll answer this in two levels. One would be an individual, but I think since you are a young researcher, I'll also talk a little bit what my organization has and the organizational policy has. So we have a remote work policy. It's not like we have a day set aside so that you can, just apply and be at home. That's not the idea. But I think what the remote work policy has helped us understand is work-life balance means different to different people. I'm single, so a woman who stays away from her family in a different city. So work-life balance to me means finding enough time for work, but ensuring that my health and responsibilities towards family is also not kept aside, not compromised. Uh, for an organization, I think it's important to have that kind of policy, and it's important to have conversations about it so that one doesn't have a one size fit all for everyone. I don't need a 1 day off every week. What will I do with it, right? So that is how organizations, and as a leader, you can approach work-life balance. I won't come to the individual thing. I would actually want a man to answer on this panel. Yeah.
Well, very right. Women are taskmasters. And personally, if you ask me, we are two vice principals who are male and the rest are all females. But but then yes, they are really good taskmasters. They are very focused, inclined, dedicated. I don't say men are not, but I always appreciate and look upon women with great respect because they play multiple roles. A woman is a wife, a mother, sister, a good entrepreneur, or maybe a worker, and multiple tasks they play. So, and they know how to balance their timings and their life. So workplace balance with movement, yes, it is much more challenging than a man. However, in today's scenario, where you find both the couple are working, man also contributes equally well, but still the role of woman always supersedes. So that's really a great job. Mayurish, you want to add?
So, for me, it will be like if I answer beyond men and women, okay? So, Deepak sir, I'll just borrow something that I overheard him, okay, when he was discussing with students while we were having tea. So, what he said was so good. Work-bank balance, your work and life balance, as we do it, it's an individual thing. But as one sees oneself, maybe 5 years in the future, 10 years in the future, whatever your plans are, then it becomes an individual's choice of how I am going to reach that plan. And if I have enough passion with me, then we find balance. I mean, you don't need to sit and find out, Arey, what will I do tomorrow? If I have passion enough, I will end up doing it. So it is my goal. It is, that may sound selfish, like, but yeah, it's an individual goal, an individual journey, and that's how balance comes. You try to find it somewhere else, and maybe that's that person's balance, not yours. So it's an individual journey. That's it. Yeah. Thank you.
Appreciate the ideas and discussions of one over here. If I would like to speak about myself, I do understand, as everybody over here, they have very well opined that yes, we need to be taskmasters, we need to multitask. Now, on a regular basis, how do I multitask? It's very a generalized term, I believe, when I say yes, I need to multitask. I need to look into my priorities, but a pre-planning, I suppose, helps to go a long way. Whatever I need to do, again, this is totally what I do, not necessarily that it has to match with all of you. Our work areas are different, our thought processes are different. But what I do is I usually try to point whatever I need to do tomorrow, maybe before I am there, or maybe before even I get up in the morning. So the previous night before I go to bed, I have on my notes all that I need to do the next day. And that's how I divide my time. I prioritize things, not that always I can end up doing everything. So I need to prioritize what to do first and what to do second and what to do third. Try and maintain a balance with my professional life and as well as my home. And at the same time, I would say that maintaining balance, to some extent, it comes on your physical health also. You need to take care of that too. As much as possible, I try to finish my plate for that day. I don't spill over for the next day. So that is my small little way of trying to keep a balance between my professional life and my personal life. So maybe each one of us have our own little way of how we go ahead. But yes, a balance is required. We need to multitask. We need to prioritize. We need to plan. These are maybe some pointers by which we can go ahead. Thank you.
Thank you for the insights. Any more questions? Yes, Mike, please.
Good afternoon, everyone. Myself, Moksha Nigol. I'm a PhD student at ICMR in NAAC. So my question would be, as from a PhD student aspect, as a PhD, when we started to ask a scientific question that we are trying to answer. But as it is a scientific question, it doesn't see it as a degree. So at the end of the journey of the PhD, still the question are still answered to be left. So, and as it is a degree, we are seeing the other people. We shouldn't, but it is a society. It's a competitive field. I also fit in very such way. We find that we are in such a position that we are left behind, and how to see ourselves and how to motivate it in this competitive world each and every day with this kind of pressure.
Yes, who would like to begin answering it first? Yes, please.
She knows what exactly I'm going to answer.
So
She's like,
actually,
no more opinion.
yeah. So actually, what I would say, regarding pressure, I would say, as I told you, first you have to be happy. You have to be happy. You know your goal, and then in that case, you should always take, what do you say? You have to take break from work also to keep your passion also going, because if you keep working, it's kind of a, the how the immune cells get exhausted, even you slowly get fatigued. At the end of the day, if you keep working whole day continuously, you tend to fatigue and your brain kind of stops or slows down. Take a quality break, maybe once in a while, take a good outing, or meet your friend, just talk to your friend, or even just talk to your colleagues in a different topic, on a different topic. I feel that keeps you kind of again coming back with your energy, and you look at your own work in a same zeal, I can say. I think that is my motto. I keep telling my staff students, please take eat on time, because your good health and good mind is going to give me more output, that and whenever they need leave also I give them, but I tell them, okay, you have to, as you say, organize, like madam said, organize your work. I am going to need, don't hide from me that your next week you're going to leave, but plan your work accordingly. Either you finish early or later, but be frank, and that is what is like, keeps everyone going, and you must have seen the slide, everybody is very happy. Okay. I think others can also opine.
One thing that definitely helps me is to zoom out a little bit, shift the perspective, and see how much of that question are you really going to get answered in those 5 or 6 years of your PhD. I think what you're trying to answer is a small part of a very big puzzle. The pressure would be these many publications, completing the PhD. I'm not sure whether Deepak is your guide, and I'm not going to give you any advice.
Go ahead.
But yes, those things need to be there is a checklist that you need to check things off that list, which are essential for completing that degree. But if the pressure is about I need to answer this question, I think just accept that you might not be able to do that completely. If you are really passionate about answering that question, that can happen post PhD. So I think that would take the pressure a little bit off. Anybody? Yes.
Two things. One is the comfort that you have with your guide, that itself solves 1,000 problems. No? And secondly, how ambitiously you have designed your problem and how well you'll be able to accomplish it. These are the two important things which needs a perfect balance. Personally, if you ask me, for me, my guide was a mother for me. So it actually solve all my issues, right? So that is very, very important. And it may happen that many a times we don't come to an agreement with the guide. But that doesn't mean that we should be drifted away. It's just a small disagreement, thresh it off, talk it out, and get it resolved. I think that will really make your life more comfortable and happy as a researcher, as a learner. Thank you. Yes.
Okay, just one, because as ma'am said, there are points that we can easily connect through, and I understand what you're saying. See, what we all in research we have all faced it. These are burnouts. You come up with an idea, you struggle through it, and you struggle a bit much. So what I always prefer, or I've always seen happening, is in case of burnouts, just search what drivers we have. Right? Everybody of us has some driver which has got us into this field. It might be passion, it might be a drive to create something for the society. It might be just curiosity. I need to know it. Okay, if we, as ma'am said, if we zoom out, just bring the driver back, I think you will be fine the next morning, because now you have reason to continue. Yeah, ma'am.
So I'm not sure how much this will help you, but maybe you look at PhD as your long-term goal and break it down into short-term goals. So after 1 year, each year, you evaluate where you are. Probably you're not somewhere ready to answer the question yet of what you began with. But you have to look at other aspects. how you have developed as a person, and probably have you developed any skills? Are you writing? Are you like able to now, like, with the literature, are you able to at least write a review? Are you able to attend conferences? So maybe when you take a look at that, as a person you are growing. So it's in the end not only the answer that you're looking at, but as a whole individual, how you are growing. So this is what I had actually learned from my guide, PhD guide, Dr. Sagarika Damle, and I still apply it to my life every 5 years. You have to remember that. Thank you.
Thank you so much. We'll just be taking 2 more questions, please.
Hello. Yeah. Good afternoon. I'm Nika, a first year student. And my question is very much oriented to a first year students who just passed 12th grade. Very general. So my question is that students who have actually took admission in BSc, they must have discovered recently that there are many options in research topics in the scientific field, and some students tend to be really confused on what to choose in future because some of us are really fascinated by literally everything around us. And so any advice for such confused students, and on how on also how to explore, on what to look at, what not to look at?
I think we had a conversation on this actually at the tea break, but I think I'll answer all the 3 questions in a relative sense. One is, I think, for work-life balance or to manage PhD or to choose a career. Number one, these are the professions you have chosen by your own choice. This is not somebody who has put on you that, no, you better be a scientist, right? So this is a choice which I have made, and therefore I will do it the way I think is the best. That gives me one idea that, okay, there will be pressures. There'll be pressures of every sort. I'll get to your question a little later. There'll be pressures of every sorts, and this is a choice that I have made. Nobody's telling me to publish a paper tomorrow morning. Yes, there's competition, but yes. Now, your question that how do I stay ahead with this competition? Why do you look at it as competition? Why are you chasing perfection? The point you're making is that which is a perfect career for me. Right, there's nothing called as perfection in science. Everything is imperfect. Work-life balance is equally imperfect in the system. Let's embrace imperfections and pursue our passion. This is what I would say to all of you. It's perfectly fine to be confused. Don't think that any one of us sitting here are not confused and very sorted. Every morning we are as confused as what we were last night. I'm sure Madam claims that she does everything previous night, but she's as confused in the morning as what it is there. So confusion is a part of life, and it is through these confusions we sail in excellence. For me, the mantra has been that this is something which I have chosen for myself because it's my passion. So I don't look at work-life balance as a pressure. And I've stopped chasing perfection. I do the day, as Madam said, that I take my break whenever I want. I don't look at these as a part of my duties. I take this as a part of the enjoyment that I get of interacting with everyone. And that's why we are here, leaving our families and everything. And it doesn't look like a failure of work-life balance. It's just that chase because we are all here for the patient. Thank you. So I think, don't worry, next year you will find some other subject which you like it and just do it. There's nothing like you start now. All of us had started on different levels, different scales. It's not the same thing which we are pursuing, which we pursued 20 years back. I'm sure things which we do today didn't even exist when we were doing our PhDs. That doesn't mean I'm old. I'm as young. But the point is that don't seek that, okay, this is what I'm starting today. This is where yes, you need to have a goal where I want to reach, like as we discussed. But it's okay to dwindle around, change the path. You'll reach somewhere which you'll enjoy.
One last question, please.
Can I answer the question?
Yes, ma'am. Just a second, please.
Yeah. So actually, to answer you, forgot your name. It was nice. Mika, yeah, nice name. So what I said, like, for us, we kind of aim at something, but we never get that. And then we feel little sad, oh, actually I wanted this. But then what we choose rest other four options. So out of this, somewhere slowly over the period, I realized my destiny. I mean, I don't know how many people believe, but my destiny got me today where I can now memorize that. Yes, slowly I had started getting increased interest in those topics. Like I used to like stem cells, I used to like immune cells. Over the period, I mean, out of that entire book, maybe at BSc, I used to land up reading those things like a stories. So I had not, I didn't take much effort to memorize those. I used to just read them like stories, any blood test or any blood related art. Actually they were chapters, but I read them like a stories. I never realized that I enjoyed them. And though maybe first I wanted to go to MBBS, then maybe I wanted to do some, actually I wanted to go to Xavier's, but I said, oh, all are tall, so tall, I cannot fit. So I went to RUIA. But over the period, I realized, okay, finally it's this, and I'm now connecting so much with Xavier's through some educational events or something. So our destined path, comes in between and kind of hints us, okay, you have to go on this path. And then you will realize, yes, actually, I walked through where my destiny went, but on the way you gather those experience, or as you know, Dr. Deepak also said, somewhere you have to start and you have to start enjoying that. Over the period, you realize you are on the path which you were, meant for. Yeah. Okay. Thank you.
Once you start enjoying, as I think all have said, as because we have chosen the path, we have chosen our career, it's because of our passion. So when it is our passion, if we start enjoying, then that force, that pressure is much, much less. We don't feel that, yes, this is something that we are doing that is forced upon us. The stress becomes less, the force becomes less, the pressure obviously is less then.
Thank you so much, ma'am. Yes, the last question for the day.
Good morning, everyone. I'm Shubhika, currently in my second year. And my question would be, at the end, it all comes down to having skills also with passion. So, as a suppose young investigator, what are the most important skills that we should work on, which most people realize when it's too late? So, that is my question for the day.
Who would like to begin?
My short answer is if you're coming for the workshop, we are actually having an activity which will help you. But yeah, it's too late to pitch that, and for others who might not be attending the workshop, it depends on what your choice of career is. What is the stage of career you are in? So the skill set will essentially be decided by that. Yeah.
I would suggest is one, the technical skills which you have to acquire what's hot today. Like as I said, AI is one of them. But beyond the technical skills, because technical skills will come and go, they're not going to be permanent. I would say acquire some life skills, communication, networking, ability to meet people, talk and interact with them. That's where you imbibe a lot of things and grow. And I think that's the best skill I acquired during my master's and PhD, which is really helping me out. So I think communication and networking skills are, I think, the life skills which, as in a research and a science career, are very crucial.
There goes some of my slides.
Yes. Okay. So there you go.
I can add a little bit. So half the battle you have won because you stood up among us everyone and you asked the question. So that is the first part of communication, that don't fear that your question may be naive or wrong. First stand up, first ask that query yourself. There may be many around you who can guide you or channelize you. You have to just keep your eyes here open from where I'm going to get answer to my own question. I think that is it.
Yes. Thank you so much. Yes. From quite some time, yes.
So, very good afternoon. I am Sriram Iyer from MSc 1. And my question to the judges was, in life there might come a point where you come across a block that's too intimidating. How should one approach that?
Well, every one of us, some or the other time, we end up facing such a wall. Okay, so there are options. Either you keep banging your head, hoping that kabhi to crack hoga. Okay, but that is not the great solution. The easier way is communicate. Okay, it is very possible that what you think is a block, somebody has already solved it. Right? Many a times that happens very easily. We get stuck because we don't speak. Either communicate. There are easy ways you can solve it. Maybe people would say, "Arey, that's a wrong wall. Left side mein door hai." Right? Just to put it comically. But many a times that's the solution. Okay, so just try it. Ask people. Ask anybody you know. Okay, read. Ask Google. He might know. Yeah, just communicate.
Other thing I would add is for again all of you is don't fear failures. The whole system that we are in is designed to train us not to fail. But a real life skill is not is failure. Embrace your failures. It's fine. Try. What the end of it kya hoga? Will fail. I'm sure Moshmi, every other experiment that you have done has actually failed, and one of them has worked, right? And that's what PhD trains you for. You get up every morning and say that okay, I'll try again. So learn not to fear failures, and all these roadblocks just disappear by themselves.
Thank you so much. I'm sure there are some more questions, but we can interact during the lunch break, please. We're running a little short of time. I thank each and everyone here on the panel for their beautiful insights. I'm sure the students have really gained a lot of knowledge through your experience. Again, once again, thank you so much. We move on to our next and the last session for the day. It's easy. Thank you. Request everyone to be seated, please. Our next speaker is Ms. Tanshi Shah, Head Bioinformatics Haystacks Analytics. Haystacks Analytics is based at IIT Bombay. It is a leading health tech company developing genomics-driven diagnostic solutions for infectious diseases. They're supported by DST DPT, among others. The company has created innovative clinical genomics products, including its nationally recognized TB genomics test, which was one of the most honored top innovations of the decade and launched by the Honorable Prime Minister of India in 2022. I welcome Ms. Sanchi Shah on stage. I request Dr. Mayuresh Joshi to please felicitate Ms. Sanchi Shah. Everyone, a big round of applause, please. Yeah. Now the stage is open.
Also, how do I?
Yeah, he helps you.
This one? Can I get the laptop? Hello? Yeah. Good morning, everyone. I am Sanchi Shah, Head Bioinformatics from Haystack Analytics Private Limited. But before I'm Head Analytics, I was actually from Mithibai. I did my bachelor's here. So I was actually the one sitting on the other side asking similar questions. But unfortunately, at that time, we did not have programs like this. So kudos to all the teachers and everyone who's arranged this program. You guys are getting an opportunity of a lifetime. So I will be talking about advances and the career opportunities in the field of bioinformatics. So what is bioinformatics, right? So bioinformatics is an interdisciplinary field where you use computational tools to go and analyze biological data to extract patterns and different insights from the data.
While we're doing this, we are also making some databases from this same data. Oops. So we're making some databases. Why do we make these databases? Is so that scientists across the world, right, who can access this data and get their own insights from the same data. When we're talking about bioinformatics, we have various different fields available in it. Starting with genomics, something that we are doing at Haystack Analytics ourselves. Here we are studying the genome of organisms to identify various patterns from them. So you would look at genes and you will look at mutations or variations within the genome to see if any of these variations lead to any drastic effect in the organism in terms of the way it is reacting to certain environment or by making it better or worse. Second is transcriptomics. So sometimes our question is not about what is the makeup of the organism, but of the fact that what is it actually expressing. So we use gene transcriptomics, which is a method in which you are checking the gene expression in the organism. This is usually done by RNA-seq as opposed to DNA-seq done by genomics. Here you actually go and see if any pathways are changed just because there has been change of expression of certain genes. Similarly, there is a field of proteomics where you study proteins, and this can be used for various different aspects because proteins eventually is nothing but your final level of what exactly has happened in the organism, which are the new enzymes, what is the change in the enzymes which is produced, and all of that you will learn from proteomics. So any kind of structural analysis that you do will be more towards proteomic driven. When you do any comparative or evolutionary based analysis, which is your phylogenetics or phylogenomics, you will use more of the genomic data. And of course, there is a utility of clinical aspect in terms of bioinformatics, where disease diagnosis, treatment, and personalizations are some of the aspects which bioinformatics can give from the data which is produced. So there are various different applications of bioinformatics. They range from drug discovery, disease diagnosis, something that we are doing at Haystack, which is rapid pathogen detection. Then you have pathogen surveillance. You have research in terms of identifying specific mutations in cells, which can help in curing help in a lot of different researches. For example, the cancer research or research against any particular drug resistance. You have personalization of medicines, where you can optimize or identify the set of right drugs which can be used to cure any particular disease or an individual. You have bioinformatics in the field of agriculture, where you can use bioinformatics to identify if there is any crop improvements, whether there is any disease which is associated. And these fields are really upcoming because climate change, right? So with the new change in climate, you can see a lot of crops having changes in terms of their growth patterns. So all of those can be actually monitored using bioinformatic applications or techniques which are there. And microbiome, I mean, we all know that now we need good health, good gut health. And gut health is going to affect your mood, and to make sure you're in a good mood to study, to do whatever you want, you have to ensure you have a good gut health. And microbiome analysis is going to help you understand your gut best. So that is one of those leading applications which are there in bioinformatics. When it comes to recent breakthroughs, there have been a lot of bioinformatics research in the last, I would say, 25 to 30 years. But if we are just summing up the last 15 years, I think after the Human Genome Project, we also have our other genome, which was produced. That is our microbiome, which was present. For example, our gut and skin microbiome was sequenced to see if any of this microbiome actually has any relevance with our clinical. So imagine your skin flora can actually help in solving some of the diagnostic aspects which are there associated with you. And all of this study is done only when you know what it is, right? And to know that, we had actually got our other genomes, which is the microbiome sequenced. This happened somewhere around in 2010 when this was published in Nature. We also have telomere to telomere. So I think everyone knows that the human genome has been long sequenced and published, right? But when it was sequenced, there were certain gaps which were not really sequenced. So while we are able to use it for our clinical utility, there are still certain things which were unanswered. Telomere to Telomere Consortium was able to sequence the first gapless genome, right? And this happens literally in the last, I think, 5 years, where they could actually give you a gapless genome which can help you answer all the questions which are associated with the human genome. Then, of course, the pandemic hit, and the interesting part about how bioinformatics helped in pandemic is when Moderna developed its vaccine, right? We all know it is a RNA-based vaccine which Moderna had developed. So the COVID-19 sequence, the first sequence was published in GenBank in the year 2020 itself on January 10th. Moderna took 2 days just to identify which is the right protein which should be targeted by their vaccine, which made the vaccine designing a 66-day process, somewhere around 66. I wouldn't say that's the exact number, but around 66 days, which is far less than the usual 5-year process. So this is how, actually using bioinformatics, they have been able to fast track their entire process of vaccine designing. In 2016, a few years prior to that, so while we have been using bioinformatics a lot, it is not just using it in our usual day-to-day labs, but it is also to see how these kind of analysis or these kind of experiments work out in extreme weathers. So NASA had actually sequenced the first DNA in 2016 in space, right? So this is basically how well and how far you can actually take sequencing, and the ability to take it in space also brings the ability to take it to different planets probably in future, right? And all of this can only happen if we try hard. So this is one of those examples which you might not be able to see that what it has achieved, but because of this, the application in future is the limits are extended, right? You say sky is the limit. I mean, this is literally the limit. This is the closest you can get to the limit out there. And 2020, you also know, AlphaFold has been released. They are able to predict the structure of proteins, which you will see in your syllabus, is a very long process. But AlphaFold can predict the structure of protein, and CAST, which is the body which is able to identify how well a particular tool, software, or a pipeline can actually predict a protein structure, has said that it has outperformed all other competitors in terms of protein structures. So these are just few of the recent breakthroughs which are there, many more to come, and many more which are not written here. One of those is that we have 10,000 Indian genomes which have been sequenced, and the project actually completed this year itself. So there is a lot of data out there which you can use. You have native data which you can use and identify insights. There are a lot of things that this field opens up to, because otherwise when you look at your traditional fields, you will feel that अरे ये सब कुछ तो हो चुका है, right? We've already done this. Where is the discovery now? But this actually gives you a lot of data and the power to discover a lot of new things. So why is suddenly bioinformatics is important? Because of the number of sequencing which is done, we have actually growing data at a much faster speed than actually expected. Because of that, okay, time's up, but just few more slides. Because of this, we are now being able to sequence the genomes much faster and at a very much lower cost. Something that you might spend at a fancy dinner, you might actually use that money and sequence an organism and study the organism to the completion. Another thing which has led is the AI revolution, right? We all know that there are a lot of new AI tools which are developed, and because of that, we have been able to unlock a lot of new scientific questions which were earlier impossible to answer. But now, with the kind of data that it has, it's able to identify a lot of new patterns. And of course, the new awakening which has happened where people are interested in precision medicine, we will now be able to get a lot of new discoveries and a lot of opportunity for people to even use this for their personalized healthcare. Another thing, if you don't believe in just growth of number of sequences, is the market projections. Some of the companies have actually projected that the bioinformatics market is showing up to 25% more compound annual growth till 2032. And this is probably the year when you guys are going to be in your peak career. So you guys need to understand that some of these fields are going to grow at much faster pace than the others, and the fact that they are going to supplement the other fields. So bioinformatics is not going to come ahead and remove other fields, but it's going to help other fields develop and answer questions which they could not without this technique. A similar thing is something you will notice, which is happening not just in India but across. This is due to a lot of funding coming into genomic research and the new technological advancements which are happening. So I think someone just asked about essential skills in bioinformatics. So there are three core competencies or components that you actually need to answer. One is you need to understand your biological question that you are asking. Second is you need to know where to find the answers for it. And third, you need to know how to find the answers. So to understand the biological question, you need to have a good domain knowledge. Here are some of the domain knowledge we've written from the point of omics, but this might not be it, right? You would have your specific question that you would want to answer. You need to know where to find the answers, right? Your answers could be in literature, it could also be in databases, because over the time, a lot of people, a lot of scientists have been able to compile a lot of their results, which some people have now been able to transform into a database. So if you know what all databases are available, you know where to look for your answer. And third is how to extract that information from it. So to know how to extract that information from it, you need to know how to use your tools. You need to know how, in case the information is too complicated or complex and engraved in a particular uh, file, say probably a genome, then you need to know the relevant tools which you can use to extract it. Now, all of this can be done much faster with Gen AI, provided you know how to use your AI tool. So your essential skills is going to be purely based on your questions. But these are some of the things that we think are usually necessary when at a generic level you are entering the field. At the career landscape level, there, according to us, there are two major paths. One is you're either going to academia or you're going to industry. So academia has more of a discovery part where people are going in asking specialized question. It has usually a lot of the PhDs usually stay in academia, try to go deeper, dive deeper into the questions they want to answer. You also have people who have done bachelor's and master's out there helping to solve a lot of questions. It gives you a high independence because your question answers are not very deadline oriented. Some of them are. Some PhDs might not agree with it, but you have a high amount of flexibility out there, and you have independence as to how we are going to approach this process. When it comes to industry, it's a little more real world impact, which means that it is more translational in nature. You would probably have some discoveries which are already made, but you want to make it available to the general audience or the public. And this is how industries try to take a research and productize them, right? So industry would be on a little more process oriented path. It would have some level of discovery, but a lot of different processes which you have to comply to. Here, usually masters students usually get into the industry, either continue their journey in the industry or they go ahead do their PhD. All both of these landscapes actually have students from bachelor's to their PhD. However, for bachelor's, I would really encourage you to do masters, and for masters, please go ahead for PhD, right? Yeah. Yeah, just 2 minutes. Okay, so currently we have different kind of roles based on the proportion of different skills that you have. You have anything ranging from a scientist level to a developer level, in case anyone is interested even into going into the tech field, right? Because later in life you realize that you are more inclined towards tech than actually bio. There are some roles which can give you that information, and ability to move your entire career path. Just last, in terms of the different uh, so when you're doing about when you're talking about industry, we are currently part of Haystack Analytics. We are leader in genomics. We are currently a health tech company developing genomic products. Our products ranges from microbial genomics to human genomics, and there could be a detailed genomic part where we are giving clinician friendly reports to a custom report which is required by researcher. We are also home to two of the most frequently used sequencers in the world. One is Oxford Nanopore sequencer, and the second is MGI DNB-seq sequencer. So we actually collaborate with a lot of researchers around the world to be able to deliver their customized request in terms of their for their research. Also collaborate with a lot of pharma companies and diagnostic companies for our products and the services. Um, as per our tech stack, we are NABL certified lab with ISO compliant pipelines. We have automated, validated, and secure pipelines on a distributed computing sequence, and we are serving researchers, biotech, and pharma companies in India and elsewhere. And we are hiring. So we are looking for interns and full times based on the different departments which are present. We have paid internship. In terms of job, obviously it's paid, but we do have internships which can range from 2 to 6 months. You guys get the hands-on on data, and you also get mentorship from scientists and developers based on which department you actually enroll in. And a lot of our interns have turned into full-time employees in our company as well. So yeah, you can get in touch with us if you are if you are interested in it. We are here also during lunch. And we have a stall out here, so please reach out if you want to know more about our products and services for your projects. Also, you can reach out to us anytime. I think there's a typo. It is career@haystackanalytics.in, not career. So extra S out there. But yeah, if you are interested, please do reach out and keep looking at our LinkedIn for any updates on future openings. Thank you.
Thank you so much. I think everyone's also got the brochure and pamphlets regarding Haystack, so you can go through that. There's a stall. We also request all the participants to visit the stall down in the foyer area and outside the college. For our sponsors, we also have another sponsor called Envision. Thank you, Sanchi ma'am, for this enlightening talk. Now we all proceed for lunch, and then we have the valedictory session. Thank you. Okay. All the participants kindly be seated for 2 more minutes, please. I know you're hungry and we're going to rush this 2 more minutes. Anushya ma'am. Okay. Okay, we would. Preeti ma'am. Yes. I would request Dr. Papya Dev to please felicitate Dr. Murali Sambhare. She hosted the session. She was a rapporteur for one of our oral sessions yesterday, and her insights were very, very useful for the participants to work on their research further. So, Dr. Papya Dev, please. Murali ma'am. Okay, Mrunalini ma'am, for me, she's my teacher, but Mrunalini ma'am is the head of department microbiology of Mithibai College. Yes, we thank you for your time and for your beautiful insights that were there. I'm sure all the faculties which presented yesterday have got very good insights on how to improve on their research and carry out research and teaching together, the most important part that is there. Thank you so much, ma'am. Thank you, Papia, ma'am. Now, I also request Dr. Hitesh Singaria to please felicitate Dr. Bindu Gopalakrishnan. Bindu ma'am is again the head of Botany Department, SVKM Mithibai College. She was the judge, one of the judges for the poster competitions for UG and PG category. So you know who you have to catch now. Thank you so much, Bindu ma'am, for your insights, for your time, and for the valuable feedback all the students received yesterday during the poster session.
My student as well.
My teacher. Thank you so much, sir. Thank you, ma'am. Yes.
Quickly, everybody assembles by 1:40.
Yes. A kind request, please rush up the lunch a little so we will have some more time for networking after that also. Kindly proceed for lunch now and 1:40 we assemble back. Thank you so much.
Good afternoon, everyone. Respected dignitaries on the dais. Our guest of honor for today, Shri Ashok Basak, sir, Advisor to the President, SVKM, and Head of the SVKM IP Cell. Dr. Shivli Mitra, Director, India Bioscience. Principal of Mithibai College, Professor Kritika Desai. Vice Principal, Research Consultancy and Collaboration, Dr. Hitesh Shingaria. Convener of the Regional Young Investigators Meet 2025, Dr. Sharon D'Souza. Vice Principals, Professor Minakshi Vaidya, Dr. Papia Deb, Dr. Kevna Desai. Our co-organizers, Dr. Kanti Kiran and Dr. Mayuresh Joshi, and our esteemed speaker, Dr. Jyoti Kore. I welcome you all to the valedictory ceremony of the Regional Young Investigators Meet 2025. We hope that the last day and a half have been a testament to the true collaborative spirit of science. Without further ado, I would now like to invite our principal ma'am, Professor Kritika Desai, to deliver the welcome address.
Good afternoon, all the dignitaries on days and dignitaries sitting in the audience, students, faculty. 1.5 day, I think so all of you had good academic collaborations, networking, and there was something for everyone to learn. And generally when we talk about the conferences and all, it should not happen that that conference certificate goes in your bag and it will be used whenever it will be required to be used. The conferences, workshops, seminars, it should be the new line. That means your networking and carry forward your work ahead. You must have had a networking with the various your participants. You must have seen that what is their area of research. If it is matching with you, please collaborate. This should not happen that you have a certificate, that certificate will go in the bag, and whenever you require, that certificate will come in from your bag. Because this is not your academic journey that you have to clear your exams or something. It is the path what you have selected. You feel that, yes, I have capability and I can present my work somewhere. So therefore, this should continue and develop a new idea. 1.5 days, we had good interactions, good presentations by the experts. Pick up some idea and see that how you can collaborate with anyone. All right. And thank you very much for as a wonderful participants, and wish you all the best. Thank you.
Thank you so much, ma'am, for those kind words. Before we move forward, apologies. Another one of our vice principals has joined us, Mr. Manish Gogri. Welcome, sir. We are truly honored today to have with us as our guest of honor, Shri Ashok Basak, sir. His constant encouragement, generous support, and guidance as a distinguished management leader have been a source of great strength and inspiration. Sir is a retired IAS officer and has served the government of Maharashtra in various capacities. He is a wealth of knowledge and experience in diverse facets of developmental administration. Having joined the Sri Vileparle Kelwani Mandal as CEO, he is now the advisor to the president of SVKM, Sri Amrish Patel, as well as the chairperson of the SVKM IP cell. With sincere gratitude for your presence with us this afternoon, sir, I kindly request our principal, Professor Kritika Desai, to extend a hearty welcome to our guest of honor, Shri Ashok Basak. Thank you so much, ma'am. Thank you, sir. A gathering of this magnitude comes to life only through the constant guidance and support of our leadership. With heartfelt gratitude, I now invite our esteemed guest of honor, Shri Ashok Basak, to address the audience.
Namaste. Good afternoon. I'm very happy to be here. I'm very thankful for inviting me as a chief guest. In fact, I don't have the qualities or the qualifications to be chief guest of this kind of gathering. But still, it's an honor. Welcome to all of you on behalf of SVKM, Sri Ville Parle Kelvani Mandal, of which Mithibai is a star institution. This institution is one of the oldest among the family of SVKM and the first to become autonomous in the family. And after autonomy, one of the important focus areas has been research. We have been trying under the leadership of the principal. In fact, the current principal has been in the forefront of this, Dr. Kritika Desai, to create an ecosystem where the environment should smell research. And I must thank her and the team, including Mr. Hitesh Singadia and all the vice principals, for creating an environment here where people will not only talk about undergraduate studies or postgraduate studies, they will also talk about research, the publications, the intellectual properties, the patents, the commercialization, sponsored research, interaction with other similar outside organizations. I'm very happy. In fact, on behalf of SVKM management, I would like to thank all of you, thank Mithibai principal and the team under her for having the audacious kind of effort which this regional meet for RYIM, Regional Young Investigators Meet. I am told this was the first time that an affiliated college has got this honor. Thank you very much. Thanks, Dr. Kritika, Dr. Singadia, and all of you for having sort of dreamt and tried to get this and get so much of very enthusiastic, spontaneous participation. Thanks all of you for having responded, having come, and I'm sure you will carry great memories of what you have learned, what you have seen, what you have understood for the last 2 days. I wish you all the best and keep on doing this, traversing this path of research in the years to come. Thank you very much.
We are grateful, sir, for your kind words and relentless support. It is what gives us the courage to go ahead on this path. Now, moving forward, I would like to invite Dr. Mohammad Azam Sheikh to convey a brief insight into the deliberations carried out over the 2-day duration of the RYIM 2025 Mumbai.
Good afternoon to all of you. To dignitaries on the dais and off the dais, it's my pleasure to present the report of 2-day Regional Young Investigator Meet 2025. This meet brought together an inspiring community of early career researchers and senior scientists across the India. We had total 112 participants with 23 oral presentation and 32 poster presentation, reflecting the vibrant research culture of our scientific community. For the first time also, we have made a YouTube live streaming of this RYM in our college here. The day one of the RYM 2025, we begin with the Saraswati Vandana, and Maharashtra Geet, followed by warm welcome to our chief guest, Colonel Professor Hemlata Bagla, and our Dr. Jayan Gandhi sir, by our principal, Professor Krutika Desai, and our vice principal, Dr. Hitesh Shingadi, and our convener, Dr. Sharon D'Souza. Even comments with the inaugural session graced by our chief guest, Professor Dr. Hemlata Bagla. She highlighted the importance of nurturing scientific curiosity and embracing interdisciplinary perspective and empowering young investigators to lead India's scientific progress for a Viksit Bharat. Our guest of honor, Dr. Jayan Gandhi, also spoke on early detection and treatment of hearing implant impairment and India's potential in the health innovation. This was followed by the engaging plenary talk by our Professor Krutika Desai. Her talk provided new insight into bacterial communication, cooperative behavior, along with the relevance to the antimicrobial and synthetic biology research. Day one continued with the two impactful mentor talk. First, from Professor Vidita Vaidya. She emphasized the impact of early life experience on brain function and encouraged the locally relevant interdisciplinary research. Followed by Dr. Mukund Goswami from Central Institute of Fishery, deliver a talk based on smart protein as a novel food for the global community. He introduced us about the cultivated meat as a sustainable biotechnology. The major highlight of the day one was a panel discussion on collaboration as a catalyst for scientific progress, led by our Vice Principal, Dr. Hitesh Shingadia, with Subhojit Sen as a panelist. They emphasized interdisciplinary partnership, knowledge sharing ecosystem, power of collaboration in scientific discovery. We also had our young investigator alumnus talk by Dr. Kanti Kiran from Gandhinagar, the title Cross Talk between the fundamental and applied research. And she showcased about the biotechnology advances in developing disease-resistant crop. The day concluded with the industry talk by Pranita Patak from SINE IIT Bombay. She explained how incubation funding, entrepreneurship help transform early stage ideas into impactful innovation. This was followed by a session by Dr. Maneka Hunjun from Springer Nature India on navigating scientific publication. She guided the young participants, research scholar, on how to select the journals, peer review, publishing ethics, and improving research visibility. Day two. The day two brought us a rich spectrum of ideas and innovation through 5 outstanding expert sessions. The first talk was delivered by Dr. Deepak Modi from ICMR. He emphasized that AI is a new language of science and encouraged researchers to learn Python and other techniques here. This is followed by Dr. Jyoti Kode from ATRAC, who spoke about think of the box. And she traced the origin of immunotherapy as a story of Jackson Laboratory and importance of humanized mice in translation immunology, inspiring participants to think creatively, which is followed by online session by Saurav Bandhavkar from AstraZeneca on scientific communication and leadership beyond the lab here, which is followed by Dr. Sivali Mitra from AstraZeneca to deliver an insightful talk on engaging communities and enabling changes. She emphasized the role of India bioscience in creating safe and inclusive space for young researchers, which is followed by panel discussion with PhD students and young researchers with a mentor and on varied topic led by Dr. Mayuresh Joshi, Jyoti Kode, ma'am, and Hitesh Shingaria sir, Dr. Shivali Mitra, and Papia Dev and Sharon D'Souza ma'am. The panel emphasized the importance of enjoying science, nurturing curiosity. Panels also spoke about the importance of embracing failure as an integral part of the scientific process. Failures were described not as a setback, but as an opportunity for the reflection. So, which is followed by a special session by Haystack Analytic, which highlighted the growing role of precision diagnostic genomic insight and data-driven analytic in accelerating the research and improving the public health line. So in conclusion, our two-day RYIM 2025 Mumbai provided a dynamic blend of scientific learning and professional development and mentorship, collaboration, and enthusiasm of young investigator and guidance of distinguished scientists made this event a resounding success. So on the behalf of organizing committee, I extend heartfelt thanks to our chief guest of honor, speakers, resource person, panelists, session chairs, and all the participants for contributing to meaningful session gathering. Thank you for your dedication and to research and innovation. We look forward to many more such inspiring engagement in the future. Thank you.
Thank you so much, sir. As we move forward, now is the part where we are going to be announcing the winners for the part who had participated in the yesterday's oral presentations and poster presentations. We'll start with the poster presentations. It was a resounding success and we got amazing feedback from the judges. So much so that in addition to the winners, there are also 2 consolation prizes, one for the UG category and one for the postgraduate category. I'll start with the undergraduate category. The poster that has won the consolation prize is P17, Mr. Vihan Kulkarni. Yes, ma'am. I request Dr. Sharon D'Souza to please hand over the certificate. The consolation prize in the poster for the postgraduate category goes to Miss Jinisha Suvarna from St. Xavier's College. I request Sharon ma'am to award her the certificate. Now we move on to the best poster in the learners category, undergraduate, postgraduate, and the award goes to P18, Mr. Akil Badruddin Samnani from KC College. I request Dr. Hitesh Shingadia to please hand over the winner's trophy to him. Now we move on to the winner for the best poster in the research scholar category. The award goes to P6, Anuradha Panigrahi from Sunandan Devetia School of Science. I would request Dr. Shuli Mitra to hand her the winner's trophy. Can we have a huge round of applause for our winners, please? Thank you, ma'am. Now we move on to our oral presentations. This award is for the Research Scholar category, Best Oral Presentation, and the award goes to O22, Kalyani Rajendra Aswale, National Institute of Animal Biotechnology. I would request our principal, Professor Kritika Desai, to please award her the winner's trophy. And now for the last prize for the afternoon, the best oral presentation, Young Investigator category, goes to O1, Dr. Anusuya Moitra from our very own Mithibai College. I would request our guest of honor, Shri Ashok Basak sir, to please hand over the award.
सर माइक्रो डिपार्टमेंट से हमारे कॉलेज वी आर प्राउड ऑफ इट.
Can we have a huge round of applause? This concludes the award presentation ceremony. I would like to invite a few of our delegates on the stage to share their feedback and experience of what they have seen here in the last 2 days. If anybody from the audience. Ma'am? Yeah, ma'am, please.
We can come one by one.
Can we have a...
So, hello everyone. Yeah, so time flies. We are almost at our concluding session. I would like to thank the organizers for putting together such a wonderful event. It has been fascinating. And This meeting provided me with an opportunity to meet with so many scholars, students, PIs. It has been wonderful for me, and I hope everyone had as much fun in this meeting as I had. And let's carry forward the networking collaborations that we have established here. We should not forget about those once the meeting is over and we are back in our labs. So let's keep forward and keep the spirit of India Bioscience and research in general. Let's keep moving forward with that thought. Thank you so much. Thanks a lot.
Yeah, good afternoon, everyone. So I thank India Bioscience and organizing team for giving me this opportunity. The event has been fabulous. The interaction with students of UG, PG, and all the faculty members of Mithibai and all who have gathered over here has been very fruitful. And collaborative talks, particularly, and today Ask Anything session was amazing, like a cherry on the top. So it was really amazing, and I agree with Madam what she just said right now. We should not stop here. We should keep having such kind of meeting, keep interacting with young minds, and keep guiding them that way. So thank you once again. Thank you, Kritika ma'am. Thank you, sir.
Thank you so much. I would now like to invite Dr. Sharon D'Souza, convener RYIM 2025, to deliver the vote of thanks.
Louis Pasteur once said, "Science knows no country because knowledge belongs to humanity and is the torch which illuminates the world." Good afternoon, distinguished guests on the dais, Shri Ashok Basak, Dr. Shuli Mitra, Professor Kritika Desai, Vice Principals, Professor Meenakshi Vaidya, Dr. Hitesh Shingadia, Dr. Manish Gogri, Dr. Papia Dev, Dr. Kevna Desai, and CA Gladys Alberts, my colleagues, mentors, friends, and dear learners. On behalf of the entire organizing committee of RYIM Mumbai 2025, it's my privilege to deliver the vote of thanks. First and foremost, I extend our heartfelt gratitude to the management of SVKM for their constant encouragement and support. Our SVKM management stepped in at a crucial time and extending their generous financial support, ensuring that RYIM Mumbai 2025 could be executed at the scale and quality we envisioned. We are deeply thankful to our president, Shri Amrish Patel, for his leadership and commitment. Your belief in this initiative has been a pillar of strength for us. Our sincere thanks to our mentor, Shri Shalin Divetia, whose guidance and mentorship shaped the direction and success of this meeting. We gratefully acknowledge India Bioscience, in particular Shuli Mitra, Director of India Bioscience. Thank you for your vision, support, and partnership in making this event a reality. A special note of appreciation for Momita Mazumdar, Program Manager, Science Communication India Bioscience, our primary point of contact. Your efforts in designing creatives and coordinating communications played a critical role in preparing for RYIM Mumbai 2025. And to Shweta, Accounts Officer at India Bioscience, thank you for your timely and efficient handling of financial matters. We extend our thanks to our collaborators, including the Principal of Kishanjan Chelaram College, Dr. Tejashree Shanbag, and Director of Gujarat Biotechnology University, Dr. Arun Bandopadhyay. Your cooperation and trust in this collaborative endeavor has been invaluable. To our co-organizers, Dr. Kanti Kiran from Gujarat Biotechnology University and Dr. Mayuresh Joshi from Kishanjan Chelaram College, thank you for your presence, your energy, and for contributing in numerous sessions that enrich the meeting. We are honored by the gracious presence of our chief guest, Colonel Professor Dr. Hemlata Bagla, for the inauguration, Dr. Jayant Gandhi, guest of honor at the inauguration, Shri Ashok Basak, for guest of honor for the valedictory session. Your time, encouraging words, and blessings have added great value to RYIM Mumbai 2025. Thank you, sir. To all the resource persons over both the days, the list is long. Professor Kritika Desai, Professor Vidita Vaidya, Dr. Mukunda Goswami, Dr. Subhojit Sen, Dr. Pranita Pathak, Dr. Menaka Hunjan, Dr. Kanti Kiran, Dr. Deepak Modi, Dr. Jyoti Kode, Dr. Shuli Mitra, Dr. Saurabh Bandavkar. Your time, expertise, insights, and generous sharing of knowledge have been the soul of this conference. As Albert Sens Georgi once said, discovery consists of seeing what everybody has seen and thinking what nobody has thought. The spirit of deep curiosity and innovative thinking truly reflects the leadership of our principal, Professor Kritika Desai. Her commitment to fostering quality research and a vision for elevating scientific culture of our institution has inspired us throughout the journey of RYIM Mumbai 2025. Under her guidance and unwavering support, RYIM Mumbai 2025 took shape and flourished. Thank you, ma'am. Our heartfelt thanks to the Vice Principals, Professor Meenakshi Vaidya, Dr. Hitesh Shingadia, Dr. Manish Kogri, Dr. Papia Dev, Dr. Kevna Desai, and CA Gladys Alberts. Thank you all for your support during the planning and execution phases. A special mention to Dr. Hitesh Shingadia. For many of us new to organizing a conference of this scale, his experience, his calm problem solving, and consistent support made a significant difference. Thank you, sir. To our sponsors, Haystack Analytics, Oc Therapies and Research Private Limited, Envision Overseas Education Consultants, Brandflow, Dragonfly Art Hotel, Sempre Joy Chocolates, Candle and Wicks, All You Need, and Aesthetically Crystals. We deeply appreciate your generous financial support, which significantly helped us bring this event to fruition. Now, to the organizing committee of RYIM Mumbai 2025 from Mithibai College. I'm sure they are all somewhere in the background or down. They're preparing your certificates or they're running around for the prizes. That's why I requested to blow up the photos there in the background. You are truly the heart and soul of this conference. Your tireless efforts, attention to detail, and dedication have shaped every aspect of this event. And I'm immensely proud of what we have achieved together. Thank you. We wish to thank the library staff, our office staff, the non-teaching staff, and the technical and support staff, without whose behind-the-scenes efforts, nothing would have come together so smoothly. And a special mention to Dr. Devang Thakkar for the same. Thank you, sir. A big shout out to our student volunteers who worked alongside all committee members with energy, enthusiasm, and commitment from morning till night, and some of you for many days. Your help has been indispensable. Thanks also to chairpersons, Dr. Subhojit Sen, Dr. Kanti Kiran, and rapporteurs of the technical sessions, Dr. Mrunalini Sambare, Dr. Shubda Valvikar, and judges of the poster sessions, Dr. Bindu Gopal Krishnan, Dr. Pranita Pathak, and Dr. Mayuresh Joshi, for your contributions ensured robust scientific discussions and fair evaluation. And of course, to all the delegates and participants. Without your active engagement, curiosity, and enthusiasm, RYIM Mumbai 2025 would not have been a success today. If I have inadvertently omitted anyone, I sincerely apologize and hope you understand that the omission is unintentional. Finally, I thank God Almighty for all the blessings showered upon us for granting us strength, unity, and success in this endeavor. Thank you once again, all of you. Together, we have made RYIM Mumbai 2025 a memorable, enriching, and an inspiring event. Thank you.
Thank you so much, Dr. Sharon, for those beautiful and amazing words. As we bring this ceremony to a close, I would request respected dignitaries on the dais and members of the audience to rise for the national anthem. Yes, we can do that. Yeah, sir, can we have a group photograph facing this side, sir? Yeah, so facing this way so that everybody can go. Yeah, if everybody in the audience can stand up, so.
Some of you come here, please.